We're going to have a lot of information here, and the way I understand it, we're going to, if you could hold your questions till the end, there'll be a period of time at the end of the presentation, we're going to be able to answer questions. So we're going to try to get as much information for everyone as we can, and thank you for attending. And we have a lot of people remote as well. So another minute or two, we're going to get this started. Thank you.
Moving your duffel bag.
Introductions, he's got many. He wears a bunch of different hats, and very happy to have him here for the presenting of this.
Hey, Paul, can't hear you.
Okay, let me bring it over here. All right. Can everybody hear me in the back? Okay. So we got to try to keep the noise down. Chris Towski is our first presenter, and again, he wears many hats, so he will introduce all the different things that he does for us. We're very blessed to have all of these presenters here with all the information that's going to be presented today. Thank you.
Thank you, Mr. Kenny. Hey, good morning, everybody. Can you hear me okay? I don't really like hearing myself, but I'm going to try to not talk directly into a microphone, but certainly let me know if you can't hear me. This is certainly going to be a tough room. It's nice to see a lot of friendly faces. Let's keep them friendly. This is obviously a topic that just doesn't want to go away, but we'll see what we can do to keep you interested. I put together something I think might be a little bit even different perspective than what I've been trying to show you in the past, so we'll see how this goes. So, again, I'm the definition of attention deficit hyperactivity disorder. I can't sit still. I have to be into something. But in a nutshell, I have 30 years in the Cambridge Fire Department, currently a fire lieutenant with 20 years in the fire prevention office. So I've been doing the codes things for a long time. Outside of that, I'm a licensed electrician here in the Commonwealth, a construction supervisor license holder. I sit on a whole bunch of NFPA standards, and we'll do a little show and tell with a bunch of them, but we got some stuff here. And things a lot of you aren't, you're not unfamiliar with. Some of you use them pretty regularly. Some of them you might be seeing some things for the first time. But on the NFPA standards, again, I sit on a bunch of them, but I'm your representative for the Fire Prevention Association here in Massachusetts. And I'm kind of a little bit of an offshoot on 855 with the International Association of Firefighters as well. But predominantly, I'm representing the Fire Prevention Association of Mass. So unlike Mr. Nunemacher, he thinks I work for the National Fire Protection Association. I don't. But I do plug them here and there because they do some really good things. And we'll talk about some of that stuff. UL is key, and I'll kind of later on in this discussion, I'm not going to dive into how UL works and how the standards apply to this particular NFPA document, because a lot of it's way over my head into the science and engineering piece of it. But I'll dive in and show you some areas of things where to look and what it's trying to accomplish. And let's give it a go. So, disclaimer, these are my opinions, perspectives, and my comments, okay? A lot of it's pretty accurate, some of it's made up. Thank you. We're never, in a short period of time, I'm going to try to narrow my end down to an hour. It's impossible to let you folks know what's been going on over the last 10 years to summarize it into 1 hour time span, okay? But we're going to try to do what I can on that side of it. So in no way we're going to be able to cover everything. Obviously, it happens a lot. More questions come out because now we'll start getting into the nitty-gritty, getting into the weeds a little bit, and you folks are going to be picking up on key terms. And you're going to want to start throwing daggers and hatchets and stuff. But we'll see if we can keep you in, get your questions answered and stuff. Not here to fight. I know I'm angry. I sound angry, but I'm not really here to fight. All right? It's the Portuguese blood in me. And let's have a little bit of fun. Nothing could be more drier than talking code and procedures and policies and stuff, but let's try to have a little fun with this. So to move this along, codes aren't in all one central spot. I think predominantly the folks, the clientele that's in the room here pretty much knows how to navigate through codes, but to just inform you that we would like them to be in all one spot. If you know how to navigate through them, it's kind of easier to find them that way, but predominantly they're not, so there's not one central, one-stop shop that we can look for, so we got to go digging around different things. Technology, especially in this space, far ahead of us. I mean, for what we're talking about now, the technology is already 10 years ahead of us. The way energy works, if you're not familiar, and I don't mean just energy itself works, but the way the adoption piece to it kind of works is that there's a big rollout that takes place in California, in the US here, then it finds its way to New York State, and then Massachusetts usually comes number 3rd in the pecking order. So with that said, we're way ahead of many other folks that are out there. But you can see that, here we are several years later, and we're still feeling like we're learning this for the first time. Personally, I'm battery saturated. I'm battery overdosed. I'm ready to swing myself off a rope out of a window or something like that from all the stuff, people have battery fire, they send it my way. And I appreciate the stuff coming my way to learn, to keep the interest. But it's just such a day-to-day thing that takes place. The good news is word is spreading. It's slow, it's picking up pace, I believe, but the word is definitely spreading. And you may not want to hear this, but I certainly see this through my lens, as I think we're sour more of the process than we are of what the codes and standards are trying to tell us. We're a little bit taken back. Well, who owns this? Who's the AHJ? Where does this sit? How do I fit into this? What am I supposed to look at? But hopefully through the info today, you'll be able to navigate through that. So what is energy storage? It's the capture of energy to be used at a later time. It's that simple. Why do we need it? For our resiliency. We certainly in public safety can understand that, we need to keep the lights on in our fire stations and things like that. Well, this is one way to get there. Quite frankly, is our supply far outweighs our demand, okay? We use, I kind of said that backwards, but we use a lot more than what we're manufacturing, than what we're making. So, again, licensed electrician, I got in the trade 40 years ago. We were changing perfectly good 60 amp electrical services for no other reason other than just to upgrade them to 200 amp so people could bring in their refrigerators, their air conditioners, their washing machines, their dryers, and all the appliances. So do we agree that we are high consumers of electrical energy? Yep. And this is what we're trying to dodge. We're trying to dodge the brownouts. Okay? We are fortunate in our region. And this is one thing I think we miss comprehending with this whole energy storage scheme, if you will, is that you go to California, I think that's somebody's emails or something that's chiming in, but it's not my computer. You go to California, they have brownouts regularly. Anything west of the Mississippi, the lights are going off pretty regularly. So we just don't have that here. We're very fortunate that our lights stay on, but we have other applications of utilizing energy storage. And this is what it's trying to accomplish. In that middle range here, with that orange line going across us, that's the peak shaving. So if you can picture, we come into this building, you go up the picture on the left, all the lights come on, even though you wouldn't know it now because we shut the lights off to have the presentation, but all the lights, everybody's coming to work, all the power's coming on. It gets to a point around midday, especially in the hot days when the air conditioner is running, that it's taxing the electrical system, right? So you might see some things, circuit breakers tripping, fuses blowing. This here, with bringing batteries on at the same time to use them in unison, is to shave that. So for energy storage with batteries, it's nothing unfamiliar to us. Would you agree? Batteries have been around forever. Lead-acid batteries. Everybody that drove a car here has a lead-acid battery. Lead-acid batteries for energy storage for generators has been around forever, 100, 150 years. It's the application of batteries that's the game changer for us. And it's the technology of batteries that we're seeing where the issues are taking place. But that's all we're trying to accomplish. They're trying to get that peak shaving, and then later in the afternoon, people start receding, shutting their computers off, going home for the night, and goes off, and what will happen will be a rinse-repeat cycle. The charging will take over for the batteries and charge the batteries up, and we'll be ready for the next cycle, for the next day. All kinds of types of energy storage. We're just not being exposed to them here again in our region. The one we're going to deal with is the batteries. And specifically, we're going to talk about the red-headed bastard child of the room, the lithium-ion battery. Here's an application, maybe in the single-family residence, somebody that's trying to get off the grid or works in unison the grid, and this is how it can be accomplished. During the day, they get their solar, it charges their battery, and then at night, the battery powers the property. This is it in a larger scale. Now here, I'm just going to back up real quick. This single-family residence piece here in Massachusetts, we have bogged ourselves down. We stuck ourselves in the mud with this because we're so amped up on chapter 15 of this document here. What I want to draw out is it's a much larger world, and we're seeing some of these, because I know some of you folks have called me up and said, hey, I got somebody looking to do this, you know, the zoning approved it, and they're going to put something in the backyard. It's the larger scale stuff that, in my opinion, is more of our worry, okay? And this is what it's trying to do. So the energy storage is that blue box on the bottom. It's bi-directional, if you will. It can take power in, so it can charge batteries, and then it can send power out and when it's needed and called on to shed, you know, to assist with some peak shaving. Here is what we're concerned in the fire service, okay? And this is what the standards are actually in place trying to combat, trying to address, and we'll talk a little bit more about that. But this here is an energy storage system. This is one of 3 in New York State that lit up last year in a short period of time between each other. There's a lot going on here. You see the 4 containers are all on fire? That's not supposed to happen. That's what 855, and we'll talk about the UL stuff, that's what it's supposed to guard against. That failed. So it's kind of not good that I say that we have failures, but we understand failures in the fire service because if there wasn't failures in the world, we wouldn't have a job, right? Okay, so that's what's taking place, and there's some other things that are going on. So let's look inside. Let's divulge and really see what our enemy is, if we want to call it an enemy. They're not all built the same. Every manufacturer is going to have their own design, own layout. But this is what it looks like on the inside, the cutout view. And there's all kinds of components. We're not going to get into, there's key things that are most important that keep things in check is that battery management system. That's the brains of the operation. But we're going to focus on the batteries, those black there with the circle with the battery array. So that's the battery array. That just means like one battery that has a whole group of them that got together. As we shrink this down, inside those arrays, you have all these battery racks, okay? So you can see what's happening. There's a container. Now there's a container inside the container. And inside this container is the battery modules or the battery packs. Those are in their own container. Okay, so you see where this is going? Now let's dive into the elephant in the room. Yes, this is 30,000 batteries that put this sculpture together. It's the battery is the problem. The energy storage isn't our problem. It's the battery. Would you agree? The battery is where our fires are taking place. So what is a battery? Just that. It's a storage. It's an energy storage device, just on a smaller scale. The name of the game in this battery industry is they want to be able to get them manufactured and produced at the lowest cost. They want it to be the smallest size out there, the lightest weight, they have the longest duration, and have the maximum density piece to it. Okay, so they want to get every big bang for the buck, and that's where the technologies come in. And I'm no super expert when it comes to battery technologies. Even when you look at the lithium-ion world, there's at least 9. I think there's probably closer to 13 now, but there's at least 9 in there. And not all those lithium-ion batteries of that family all go into this thing we'll talk about, this phenomenon, this thermal runaway condition. So this is what some batteries look like, traditional shapes. We all seen like the ones on the left, and we'll talk a little bit more about those, but we'll call them cells, but those are our cylindrical ones. The prismatics we've seen, those like you find something in a fire alarm control panel, and then the pouches. Everybody come in with a cell phone today? Everybody have a laptop computer? That's what's in those. They're pouches. They're able to be shaped and formed. The cell. This is how it works in their industry. All different sizes. Mostly the car manufacturers are the tall one in the middle there. But the predominant one that's out there that is this 18 millimeter by 65. So it's known as an 18650 out there in the industry. That gets used a lot. This is how a battery is kind of made up in a high view. It has a lot of things that are wrapped inside. So if you just keep taking sheets of paper, put sheets of paper together and then roll them up, that's essentially how you get a battery. And it's all those components that are inside. And we'll talk about what those components are. You only need 4 components. Yeah, there's a whole bunch of other junk that goes along, but essentially 4 components to make up a battery. The negative portion is the anode, the cathode is the positive, and in battery world, it's direct current. It flows negative to positive, so it flows anode to cathode. You need the solution, or I shouldn't say solution, you need the electrolyte. The electrolyte is pretty much that prime mover that lets the things sit in place so they don't short circuit. And then you need a separator. You need something to keep them apart so they don't fight. Because they'll magnetize, and that's how essentially they work. So that's what the separator does. You can see when we go from our lead acid battery, which is essentially on the left, it's wider, it's bigger. It's kind of condensed to get the same energy, the same density, to solidify the electrolyte is how this battery industry is essentially working. And the more that they can get to compress and to solidify, the smaller and the denser the battery can get with the same kind of electrical outputs. Now, we've known batteries, right? We've had AA batteries, D, C batteries. What did we always do with those batteries when they were done? Chucked them, right? We threw them away. Now we're in this world of recycling and repurposing, if you will. So this is what this industry realizes that they can capitalize on. They can market. And that's what they do, and they get really good success. So now you can do things to charge them. So this charging piece takes place. You can see just when it's being discharged, when it's on a load, power's flowing one way, but when it's not on that load, you switch it over and you get it onto some type of charging equipment. In this space, though, this is where the battery is at its best. Traditionally, it's really 20%. So all your phones, all your cell phones, you know when it says empty, dead, or whatever you want to call it? You're still at 20%. It's never fully depleted. And you know when it says full or fully charged? You're at 80%. You're never at 100%. Okay? They don't tell you that because they need that buffer space. Kind of like, remember when we went to, for the fire folks, we went to gas school, they told us about propane, and you got that volume space? It's kind of the same thing. There's an area that energy needs to go. Okay, but what they show us as full is really an 80%, and what's depleted is really a 20%. So there's that margin there. And this is another area that the industry, the battery industry, is trying to master and perfect. Because no sooner, I mean, as soon as we get this whole lithium ion thing figured out, we're going to be in something else like salts. The lithium ion probably won't last forever, or will be overdone by somebody else. So, not all of them this way, but what I want to show, especially the fire folks, because the fire folks, we get tripped up, again, on terms. And I want to just point this out to some folks. The word lithium has a tendency to stick in our foreheads as fire folks because we think the worst is going to happen. Because we think that, oh, it's water reacted, if we put water on it, things are going to explode. Yes? Nobody thinks that anymore? Okay, so nobody wants to raise their hand. Okay? But we do. We're hung up on the word lithium, and we're hung up with our eyes telling us and entraining us that everything is a hazardous material in this space. Okay? Right? Yes, thank you. We are. We're going to get over this. Okay? What I want to show you here, this is a lithium-ion battery. 7% of actual raw lithium is used to make up this battery. It's a whole bunch of other stuff that makes up the battery. Okay? So kind of think of it with air. Air is only 21% oxygen. It's a small percent of stuff that, the stuff that we need to survive, but it's all the other things that are there. Same thing that goes on with a lot of these batteries. Okay? It's just a small percentage. And once it gets converted through chemistry from its raw lithium state into a lithium ion component, it's no longer that dangerous and reactive as what it used to be. Okay? So, and what they produce, though, is that they have very good charging cycles. It's that state of charge that we talked about is kind of that mishap. And there's a lot of elements to inflict failure into batteries. I took the slide down, but it could be punctured. It could be done something intentional. It could be just natural wear and tear. It could be like me. My mother always told me I was the bastard child. It was, it was somebody that was just born nasty, just had, come out of the box that was bad. There's other factors, there's environmental things. It could be manufactured or installed incorrectly. There's many, many factors that could cause a battery to fail. But when they fail, though, what we've learned with the chemistry of these batteries is that they off-gas, and what they off-gas is very flammable, explosive, and very toxic. Hence, a lot goes into this thermal runaway condition. Okay, this is this phenomenon that takes place. And essentially all it is that it's rapid fire, potential rapid explosion, but it's self-sustaining because of the chemistry. When you go through the battery, through its normal state and walk it through as heat's applied to it, when you get to that end result, a component that's off-gassed is oxygen. So for the fire folks, and most layman folks know this, you only need 3 elements to survive for fire, right? Something to burn, well, that's the battery case, and maybe some of the components inside the battery. Heat, well, the heat's already been applied, because it's a part of a natural thing for it to survive, is heat is there. It's an electrical component, so there's natural heat there. And now it's producing oxygen. So it's a self-sustaining component. Why they burn, again, there's some interacted failure. Usually it's a short circuit, some overcharging aspect. This is what we're seeing with the negative media aspects, all right? Who here, especially in the fire service, is tracking, I don't know, fire engineering, Firehouse Magazine? You're watching FDNY, they put out the FDNY tips. Nobody? Nobody on the fire side is watching that? Okay, but do you agree, though, that even the news, you're seeing, yeah, I'm not saying that there hasn't been battery-involved fatalities in New York City. I'm not saying they haven't existed in Australia. I'm not saying they haven't existed in the UK. That's well known. But you're only hearing the media aspect of it. Okay, we're not hearing some of the other stories. What was going on? Well, they were improperly charged into a whole bunch of extension cords. They were knockoff overseas purchased batteries. They were knockoff overseas, or whatever, maybe even made here in the States, chargers, not compatible. There was manipulation of the batteries because these folks, what a lot of them use them for is their delivery service, and they're trying to extend their day. So they said, well, geez, there was one battery that came to the bike. Maybe I'll try to modify and solder on a second battery. That's the stuff we don't hear. And then granted, there is some components out there that is able to slip through the cracks or get into the industry through the consumers we buy all the time. I'm guilty of it. I shop Amazon all the time. I'm not checking where my stuff's coming from. I'm hoping it comes with some level of safety. There's some standard of care out there that took care of that. But some buyer beware on top of it, okay? So if we try to look at this, I thought this would be pretty cool. Maybe I'll get this one squashed in my head. But if we look at stuffing, turkey, and I don't like turkey, but I love stuffing. If we look at making stuffing, and if you take that stuffing and you put it in the bird, and then you wrap the bird with foil, and you put the bird in a foil pan, and then you close the door. This is what I'm getting at. So say you take all that. So if you had in your oven, if your stuffing caught fire, could you put the fire out? Probably, right? But what if I told you, you can't, it's covered, okay? So you have an access issue. It's enclosed. You can't open the oven door. You can't shut the fuel supply off to the oven, okay? The pressure is increasing in the oven because it's off-gassing, it's burning, okay? So it's looking to keep that going. The pressure finally weeps out of the oven because not all ovens are perfect, right? Some vent holes and stuff. So now the pressure's getting out and some flame might be coming out. Now the chemistry in the stuffing itself is starting to change, where its DNA makeup made it that when it does burn and gets to its ignition temperature, it actually does another component and produces oxygen. Okay? So now what would your decisions be? I know this is for everybody for the most part, but it's certainly for the fire folks, and this is where we're getting tripped up. Water. Water is your decision. Water, for the most of us, you bring it with you. You have it available in your community. It's proven, because that's what these need. Batteries need to be cooled. It's not going to be perfect. It's going to be ugly and messy, because now you're just going to be throwing water at the outside of an oven for a while, so you're going to have to be there for a little bit longer. But eventually, things are going to cool down and get to a certain place where you can start maybe opening things up. What you don't want to do is pry open batteries, okay? And then water, now you just got to be careful when you do your water and how you apply it, because water on undamaged components can cause damage. So you could actually might be making your problem a little bit worse. Or if you decided, geez, a Tesla had a contents fire, but it rolled over the guardrail, and I just want to open it up so I don't have a battery fire, and you start prying things open, well, you could be subject to harm there. You're causing a breach, so you could be causing a short. And then if you introduce water, yeah, you could be causing a breach and causing a short. But outside of that, hands down, if the fire is outside that box, throw water. Water is your only saving grace. Yep, you're going to see a lot of products out there, and I support products. I want to see products survive. I'd love to see blankets. I'd love to see water additives to fire extinguishers and what we could do to treatments to our fire suppression water. But until all that stuff gets played out through laboratory scientific testing, do yourself a favor. Just use what you got. Okay? Just anticipate you're going to be there longer, and it's going to be a little bit more time-consuming for you. You know what I mean? It's going to be a little bit more troublesome. You might have to do some stuff post-event, get touch base with manufacturing. I dove into the car world, but the same kind of thing could take place with the stationary stuff. So you got to work hand in hand with some folks, okay? It's just going to change our strategies and tactics a little bit, but not crush them, okay? Because those, again, those are some of the high-level things that we get the feedback aspects from the fire service. They're thinking it's a hazmat automatically. They're thinking that they can't use water. They're thinking that they can't do anything. No, there's still a lot of stuff you can do. You just got to do things a little different. Is that fair enough? All right. Codes and standards process. By no means are they perfect or as accurate as we'd love them to be, and I hate to do death by PowerPoint, so I'm going to try not to read every line by line. They're written by us. So whenever anybody's aggrieved in regulation, you have a voice. The NFPA books used to put it right in the back on how to do it, but now you can do it right online. The BFPR, we have a process here, and congratulations to Chief Fisher, by the way, but they have a process here. He was appointed as the chair of the BFPR. We have a process here. Use the process if you're aggrieved by it, okay? Let's not just sit on our thumbs, oh, geez, I hate the way this book, I hate the way NFPA 855 was written. No, those people are knuckleheads. Well, guess what? They're the same people as you. It's us. The NFPA doesn't write standards. They're a publishing house. We write standards. The ICC, they don't write books. It's us that sit on standards and committees that write the codes. So get involved if you're aggrieved by something. And I agree, nothing's perfect. And I will talk a little bit on the development of the 855. It's a consensus practice. It's highly technical, especially in this space. I don't know how many of you folks have looked through 855, but it's daunting, it's challenging. You gotta be in that arena. If you look at our DNA makeup of the committee members, we started out as 32. I was one of the original. Even then, there was only 4 of us from representing fire industry, fire and building code industry. Now we're up about double, we're up about 72 people, because there's some voting alternates and stuff like that that are able to play. We're still very low represented. I think there's only 6 of us that represent the fire service industry. The biggest representation out there is the industry, the battery industry. The good news is that they want to play ball, okay? They do want to play ball. I know here with some of us, because I've had the same thing with some of the folks on the street level. You know, for example, Tesla. You know, Tesla is a big cat. Tesla was the first one out there to call out all the other battery manufacturers and say, go burn your stuff. We're doing it because we want to know how safe it is before we get it to our consumers. So go challenge everybody to go burn their stuff. But I get it. Sometimes us, when we work on the streets and we're working with some of those folks from those companies, it's a little challenging. It's like we're talking to ourselves, talking to a mirror or whatever, you know, talking to a wall, trying to get our point across, all right? But big level, take my word for it, these folks are in this space, want this to work because it's a sign of their industry. If this doesn't work, they all go bankrupt. They all go pause up. And they're highly needed. One thing you need to know, or you should know, is that this is a big driver through the Department of Energy. The federal government needs this. It's not just a want, it's a need for energy storage to survive. We need to play along with this so we can help them get there. Now, I know it's not going to be perfect, but we have to do our part. And then the adoption process is slow. Again, we're spoiled here in Massachusetts. We're looking now at the 2024 editions of code, which just recently published and put out there, but other places aren't as robust as we are. So again, consider yourselves lucky in that aspect, but we're working on it. And so we're working on the 2026 version of A55. That work started last year. We already started putting that together. So by the time it gets printed out there, it'll be another 3 years. A lot of that info is 4 years old. So just think and imagine how technology has advanced in that 4 years. And that's where, I'm going to use this word a lot. A good friend of mine that's on committee, he uses this term, and I already mentioned it once today, standard of care. Keep that in the back of your head, because that's going to fill in the gap when codes don't point blank of what we are here to enforce and what we've adopted. It's seeing where things are trending and how best practices really going out there, and that this will help you align all that stuff. So this is what code's supposed to look like. I put this up to be funny, because this is what code really looks like to all of us, okay? All right, it is. You know, I'm, again, just as guilty of it. I know even anytime there's a code change, going to the electrical code or fire code, you know, if I'm not part of it, my head spins. So let's try to get there. Now, hold on to your seats, all right? This is going to be one of those wild Disney rides. Nah, just kidding. So I'm a firm believer, especially, again, being in the fire prevention office for so long and had so many people come in after. It even happened to me. When I came in the office, they handed me a book and said, here you go, kid, run with it. To me, I think it's very helpful to know not only the words that's on the page and how to find those words, but what the words really meant. How did the words get there in the first place? That's one of the things we've been doing. I don't want to make it be a sore subject for Mark here, but what we were doing with the solar stuff. You know, we pumped the brakes a little bit. We looked back to see, hey, how did it get into code in the first place? So we could try to line it up to see what folks were thinking to get to where we want to go for the future of it. So if we look historically, a huge problem was taking place overseas. Korea at the time had 31 known energy storage fires, large fires, okay? And then we had some stuff with U.S. territory in Hawaii and the islands of Samoa. It's not ended. We've had stuff in Moss Landing, California, twice. We've had 3 different mishaps in New York State, different locations. You know, so we're not immune to it here. But again, you got to look back and see when those were installed and what was really in place for some regulatory things. And there probably wasn't a lot, especially stuff that goes in under utilities. So the California Energy Alliance reached out to the NFPA. The NFPA has this organization, the Fire Protection Research Foundation. They threw them some grant money and said, hey, what can you do? So in 2016, they launched a program, a project, to see if there was even going to be a market, to see if it would be palatable for a new document. And boy, it was. And NFPA 855 was launched. It started out as pulling, for folks that know fire code, it started out pulling Chapter 52 of the fire code together, and another section, NFPA document 853 for fuel cells. We went a total different direction from fuel cells. We started out with some baseline stuff from Chapter 52, which you folks that are on the fire side saw some of that when we adopted the 2018 in October of 2019. Okay. We got stumped. So like I mentioned, the utilities want to claim that they march to a different drummer. And to some degree they do. There's this thing called the IEEE, and it's not like they're not regulated, they're just regulated differently. So as they were catching wind of this, they're like, no, doesn't apply, turn the nose, come to find out that it does apply to them. So it stopped everything we were doing in production for a year and a half, because it took time to get their industry onto the committee and start the ball rolling again, okay? And for folks that are in the regulatory space, I know us as enforcers, that's all we can enforce, I get that, but they're the bare minimums. It's always acceptable for folks to go above and beyond. So to get to the NFPA side of it, Chapter 52 carried through several cycles, started in 2003, carried through all the way to 2009, just known as lead-acid batteries. In 2012, it changed its name because things are starting to align. You're not seeing this. You know, this is going on 10, 15 years ago, but folks out there in the world of regulatory knew things were happening, so they started with little subtle changes. So the title in Chapter 52 changes to stationary battery, still kind of read the same thing, That carried through for another edition. In 2018, it changed its name to just energy storage. They realized they didn't need the stationary and they just wanted to call it energy storage because, again, they saw alignments taking place. They saw that there's work going on over at the ICC, there's work going on here at the NFPA, there's work going on in the IEEE, all over the place. And to line up stuff, they're trying to bring things together. So, and then that carried through 2021, which is what Massachusetts currently uses. So, as we rewind the clock, the first edition of 855 comes out in 2020, and you see things are starting to match up with some terminology with what was going on in NFPA 1. The 2024 edition of NFPA 1 should be real easy for those folks that promulgated on our end, because all the language that's in there now should just be all deleted out. It's just going to say, go to NFPA 855. There's a ton of work taking place right now for the next edition. We thought we did a good job revamping it from the first edition to the second. We know we have a lot of work, and we're hitting it hard with gas explosion, venting, and looking at suppression, because there's some confusion that goes on suppression, because again, same thing happens. People jump on bail language. They think, oh, geez, I have a clean agent. I'm going to solve everybody's problems. Oh, and they get people to buy into it, but the clean agent doesn't do what it's asked to do. Because what folks need to do is really have to evaluate what the hazard is that they're trying to mitigate. And there's tons. Half the book is annex material. Okay, so just, even though it's not enforceable, but take a look at the annex stuff, because it's going to get you in the mindset of what folks were thinking on committee. So, as I kind of already alluded to, the ICC is picking up. They're doing some stuff. They didn't have anything in certain editions. I believe, not as a failure, but as a factor here for us in Mass, because we missed the 2018 editions, we didn't get our feet wet in some stuff. Because the 2018, both in the ICC world and both in the NFPA 1 world, introduced us some stuff. Mass here adopted some certain stuff out of the 2018 NFPA 1, which chapter 52, but it was really only because of the name change. It wasn't really much different than what the previous wording said. But nonetheless, we definitely, that's why I'm proud of us here in Mass, because we may not always seem it, but we're a little bit ahead of the curve in some of the stuff. But you can see, if you follow the additions along, the things are mirroring. At each step of the way, the ICC is mirroring what the NFPA 1 world is doing. And you'll see that when the 10th edition rolls out. As long as it stays pretty much word for word of what has gone forward so far, you'll see that carry over. Both in the IFC, which is not used here, we know that we don't use it here because we're an NFPA 1 state, but the IRC, the language that they directly extracted, will carry over. And it's, again, verbatim of essentially what chapter 15. And then the 2024 of the ICC is expected to do the same thing as NFPA 1 2024. It's supposed to just point directly to 855. Take all that other language out of it. So here's where it gets key. And I think this is something that we miss. 855 is heavily crutched upon on UL. UL standards is really what drives a lot of the 855, okay? And I think that's where we might be, you know, when we get hung up with some of the stuff we look at in 855, that might be why, because we don't understand what the UL stuff is trying to tell us. But this is just some of that stuff. Some stuff covers cells, the battery. Yep, there's even a home for repurposed batteries and what takes place in the inverter. That's when it converts the DC to the AC. But what you see highlighted there, those are pretty much the key ones. 9540 is the safety factor, is the safety. You know, I know we look at 855 and say, well, this doesn't make sense. There's loopholes here. If you look through it, and when it looks for that UL 9540 qualification piece, that's what's supposed to fit the gap. Now, 9540 and 9540A, well, for starters, people think 9540A is a pass-fail. It's not. 9540A is just the component to and complement 9540 in any technology that may go into thermal runaway. So if I'm a battery owner and I want to know if my battery will go into thermal runaway, I will put it to these tests. But the tests just give me data. They're not telling me that I passed, failed. Essentially, I mean, it all depends on how you want to look at it as the viewer. If the battery caught fire, I guess it failed, right? But that's not what they're looking for. They're actually looking to burn the battery to get the data off it to see how it performs. So then once they know how the battery performs under those fire conditions, then they can start putting components in place to mitigate for that when the battery goes into the systems. So that's how it all comes together. So some other stuff I mentioned earlier, NFPA 68 and 69, looking for the explosion and the venting prevention pieces. The electrical code, I don't know, I know we have few electricians in the room, but the electrical code saw this first. NFPA 70, the electrical code, chapter 706, was the first to see anything on energy storage. So to give you some comfort, some peace of mind, at least electrically sound, if folks were following that, which they should have, you know, at least electrically, it should be put together pretty well. Doesn't, you know, say that it can't still have fires, but it should be put together well. So in a nutshell, 9540 is the entire system. 9548 complements to understand those risks for the battery-specific technologies. 855 is just to bridge them, okay, to bridge all the industry best practices and what goes on in the UL world of safety standards. It doesn't have to be UL. We just predominantly use them here in the States. But whatever NERDL, National Recognized Testing Lab, that these folks can go and get a test done to evaluate their equipment, that's stamp seal of approval of the safety component. And the irony here, and this is one thing as fire service, we have it's a tough nut to swallow, is that it's expected to burn. There is a level of expectation that through all 855 and UL 9540, 9548, that the battery, if it has a failure, it burns. It's just that the burn isn't supposed to leave the box. Or if the burn leaves the box, what does that look like? And what things go in place to stop it or slow it down from leaving the box? So this is us in Cambridge. This system just showed up. This is 2 different battery arrays. You can kind of see it split in the middle, almost where that light pole is. All lithium-ion batteries. Showed up out of the blue about 6 years ago. Fortunately, though, the individual that reached out got directed my way, and I was trying to do whatever I could to support their efforts. This will take the facility completely off the grid if they need to, 100%. Originally, that was their target. Then they said they couldn't get that because they needed more batteries, but ultimately they were able to do that. And the way this one's activated, if you will, it's natural gas. So it's not no electric coming into it and electric going out. It's natural gas that comes in. The gas does not get burnt. It gets compressed. So you compress the natural gas. The byproduct of that becomes hydrogen. So it's a hydrogen fuel cell that does this, and then it supports that facility. So I'm going to give a good segue into my good friends here for the, well, actually, I think Mark wanted to do something, but as I lead into Kristen and Jake,
I deserve that.
the 1 and 2 family component, I kind of left this, again, to give them a good segue in. I'm not going to dive heavy into this, but what we did do is, we previously had the 2012 and 2015 NFPA. When we had that, Chapter 52 existed, nobody batted an eye. Chapter 52 was already there, already talked about energy storage, but nobody cared, okay? I shouldn't say nobody cared. Nobody was really watching it until things really started coming out of the earth, and we started seeing these pop-up, hey, now I have small companies. I have Generac, I have Tesla, and they want to put batteries into these properties. Okay? So what Mass did, not just for that, for the 1 and 2 family, for all of it, but it was big taker in the 1 and 2 family. We adopted that Chapter 52 in 2018, out of the 2018 code in 2019. So again, it kept us ahead. We still might feel like we were lagging behind, but it kept us ahead. Some good points there, I still question, because I question everything, but the permit, I think it's great that the permit, so it triggers a fire department permit. I support that. I just don't know what the content of the permit should be. You know, where there is a generic permit, and I know Kristen or Jake will show that in their presentation. Yeah, that's great. Name, address, you know, but I think we probably need a little bit of legwork here in the Commonwealth to really put components of what the permit should be on there, what info should be on there. I think there should be some more specific things. And it hit it hard. Mass amendments hit it hard with the 1 and 2 family. It added a decommissioning component. Was never intended for 855 to add decommissioning because it's going to be challenging, but it's there, so at least there's an accountability, so that's a good thing. And it added a whole bunch of stuff that I know Kristen and Jake will rifle down through that laundry list. A couple of guidance documents came out. They've been sunsetted. They're still applicable if they were in that time frame when an installation took place. So if something took place in May or June of 2021, they were able to be looked at, but they're no longer used anymore because we've moved on from that and we've gone into more adoption of 855. And that's what it's trying to target. So me personally, This may be our biggest ass ache out there, what we're dealing with today, but in my opinion, this is the least of our worries. These are designed in, they're not gonna be perfect, but they're designed in that if they have a failure, the failure kind of stays inside the box. We've put some stuff in regulatory to help that, you know, to protect if they're in spaces. And that's kind of where it is with that. But again, not that, and I'm not even sure that we even have any data of any of these burning up. There probably is, but it's not high. You guys might see it, you know, from the Commonwealth side, but I'm not getting the feedback. You know, I mean, I'm not hearing those being as problematic. But in respect, there's probably going to be a lot more of these at some point, so it'll be catch up. You know, it's kind of the same dialogue that's going on now. Well, geez, electric vehicle fires compared to ICE vehicles. Well, look, electric vehicles is this number out there as opposed to gasoline engine vehicles. So when you get the numbers even, then start playing out, you know, one for one, who's having fires, who isn't. Because right now the media is trying to say, oh, they're more, they're worse. Wait a minute, no, they're not. Now, holistically, they're not. They're a little bit more challenging, but they're not worse. Those e-bikes, those scooters, those are definitely big problems for us in the battery world. And then we'll see where these are. A lot of these, I know, it's tough up here in our region because they should be outside. You know, for most of us, I think we'd all be comfortable if they were all outside. But for the most part, they can't be because we have crazy, funky temperatures ranges here. You know, our cold is going to hurt them more than the heat. And then it kind of defeats the purpose. But again, it all depends why people put them in. Some people are just putting them in kind of just because, you know, they're not really trying to get themselves completely off the grid, but maybe if that doomsday comes, and they'll be all lined up that they can do that. So, that's that piece. How'd I do? Good. Any questions?
Touch on those battery storage, like where they're allowed to be stored inside the house, things it's only based on the fire rating and stuff it's supposed to have.
So to back up, because this is where the question kind of
Chris, can you
stuff.
repeat his question? I couldn't hear.
Oh, the question, sorry, I usually do that too, thanks, Mark. The question was, can we elaborate on where batteries can go inside of a house? I'm kind of jumping ahead, because you'd probably, so, my comment is gonna be, because I'll probably be leaving anyway, my comment, and I'm not necessarily here defending 855, but I wanna let you know, Chapter 15 of NFPA 855 was like what my mother used to call me, the bastard child. It was an afterthought. We weren't geared into that. We weren't looking at small stuff until somebody raised their hand up one day and said, hey, what do we do with this? What kind of carve-outs can we give them for relaxation? So 855, Chapter 15, I don't want to say it was just hodgepodge thrown together, but it didn't get the time that the rest of the document got. And on top of it, it's not a building code. It's a fire code aspect. So that's why the terminology, especially where we talk about utility rooms and utility closets, it wasn't expected of this document to tell you what those were. We just don't have really clean definitions of what a utility closet and what those spaces are. I think the building code might have some stuff, and I'm sure they can, you know, feather in more commentary. But that's why, you know, this whole 1 hour rating. To quash that here, the 855 didn't care that it went inside of a building. 855 only cared that it wasn't going to be, if somebody was coming out of their bedroom, they weren't hit with a potential ball of fire in front of them. But outside of that, it didn't necessarily care where inside. But it did care that if it went into a space that wasn't protected, if it was open wood framing, it didn't want that fire, if it left the box, to get into that framing and consume the building. So it put gypsum wallboard. But the only time that it can refer to a gypsum wallboard, it has to say gypsum type X. There's a rationale for that. I don't remember why, but it had to say that. Here, our minds think of that, 5/8, hourly rating, and what it was trying to accomplish. But this was never intended to try to put an hourly rating. It was just trying to get it better that if it went in a space that was a little bit less protected, should there have been a mishap, it would go on. And they're kind of the same, we've had this discussion over the smoke detector language and stuff that's in there. So that helped. So, you know, and for one thing, 855, in our first edition, basements weren't covered. Massachusetts brought basements in, and it had to, because, you know, we have a lot of those properties here. But we had that thinking that, no, they shouldn't be below ground, you know. That's how some of the fire folks were looking at it. But nonetheless, it's here, and it found its way in, so it's here to stay. It's in the second edition that it can be in basements. And again, a lot of that Chapter 15 language, no doubt, could be cleaned up. Send in your comments. You might be at a point in time, though, it might be tough to get those comments because I think we've gone beyond, so the way the process works, you go through this open period of public input. Once that closes, it goes to committee, they start putting subgroups together, start setting the stage for first draft, and then the public comment stage will get opened up. If you see something that was opened up in the original PI, it might have been squashed, but it's not dead on the floor. The only thing you can't do now is introduce new language. You gotta wait for the next cycle if there's something that you really agreed from. But that's my view, you know, on the whole overall scheme on how it came together. So hopefully that gets you a little bit better off than where you were 45 minutes ago. Anything else? All right, as always, I thank you for your time. I'll see you next time.
Thank you, Chris.
Thank you.
Perfect. Okay. Awesome. Hi guys, everybody. My name is Mark Durenberger. I'm the president and founder of New England Clean Energy. I'm here to speak about why batteries have become so common and what's driving them. A little bit about a background about me. I'm the founder and president of the company. I've been doing this now 17 years. So I've been in the business a long time. I'm willing to bet that more than half of you out here have inspected work done by my company. Hopefully you were happy. We try very hard to make the jobs go well. We primarily serve residential customers. We have yet to do a commercial battery. I don't see it in my future. We've done a few commercial solar systems, but mostly it's residential solar, residential batteries. Back in the early days, before lithium ion became a thing, I did do a few battery systems. They were lead acid, and I best describe them as Frankenstein, because I'd get the inverter from one company, the batteries from another company, a cabinet for the batteries. In fact, I built the cabinet once in one of the projects. I mean, they work fine. The downside is lead acid takes up a lot of space, and they degrade eventually. We did a system in Northborough. Mr. Berger, is he here? No? He was the inspector on the job, there was no fire code or anything back then. This was a long time ago. The system's like 12 years old now. I've heard from the homeowner, the lead acid battery is operating at best half of what it did when we installed it. So over the course of 12 years and moderate use, it's faded. Its capacity has dropped quite a bit. Things are different now. As Chris pointed out, all of these are integrated systems. They're all tested as a system. Individual components are tested. Way more robust than anything we used to do. Let me just qualify. I don't speak for all of the solar companies out there. I'm fairly heavily involved in what's happening at the code level. I've been working with the General Requirements Code Council to try and get some tweaks to the ridgeline setback and working path code. I've been a board member of the Solar Energy Business Association of New England. I shake my head whenever I hear of some of the stuff that you guys see out there. It disturbs me because it makes everybody's life harder when you get these hacks out there or these people trying to cut corners. But I don't represent them. I'm just telling you what we're seeing and what's going on from a battery perspective. Why batteries all of a sudden? A little bit on battery chemistry and recycling, firing, safety. Most of this, Kristen and Jake are going to handle way better than I will. Some limitations on batteries, Chris already alluded to it. I'll tell you what some of the incentives are, why people want to do them from a financial reason, and then I'll show you some pictures. The sudden interest has come about from 4 major things that have happened. Grid reliability, something called the duck curve, which I'll describe in just a second, grid capacity, and then new products. All of these things have come about to drive what's going on in the battery space. Grid reliability. How many of you remember the winter of 2021 in Texas? 4 million customers lost power because their grid wasn't winterized. Climate change is playing a role. It's throwing off the seasons. It's making winters worse, summers worse, all these things. I have a friend who was a nuclear power plant operator, and he described, he wasn't down in Texas, he's retired now, but he said there were water lines that froze going into some of the nuclear power plants When they lose water lines, which are coolant, they have to shut down. And this is what happened on at least a couple of the nukes down there, right? And then people were trying to burn their furniture in order to stay warm. Meanwhile, California has had serious droughts, which caused massive wildfires. The utilities are largely to blame because they would take money as profits rather than use it as preventive maintenance and cut back brush from equipment. The equipment got really hot, started fires, and so the way that the utilities decided to deal with this was rolling blackouts. Oh, we don't want that equipment to heat up, we better shut it down, right? And so people are suddenly without power. Batteries become really popular in that environment. So those are two major factors to drive batteries. And we'll talk about time of use, which is something I'll get to in a minute, right? The thing that we've got to do occasionally is go back and make sure that all our bolts are tight, all the nuts are tight, right? Because if things loosen up, just like in a car battery, you get a loose connection, wires rattle, whatever. But basically, there's not much to deal with. You don't have to keep putting fuel into them, propane or natural gas or whatever. How many of you have struggled with getting a generator started this winter? You know how much fun those can be when your hands are freezing and the power's out and you're trying to get that thing going, right? We have replaced a couple of whole house generators that failed. I don't know if you remember, there was a tornado that touched down on the Cape a couple of years ago. A homeowner called and said, hey, my generator didn't start. I think he bought the house and the maintenance hadn't been done on the generator before he bought the house. And he said, I want a battery. So he basically took over the infrastructure and replaced it with a battery. The batteries are automatic. The transfer switch is so fast that the digital clocks on your microwave do not reset. I swear to God, I've sold batteries just because of that feature. You might see the lights flicker on when they flip over, right? And depending on the size, the implementation, and how you run your house, you can ride out most outages. The duck curve. So what happens is, as more and more solar gets deployed in an area, during the day when it's sunny, it drives down demand from the fossil fuel generator plants. So if you're, some big generator and you have a big natural gas plant, you like to run that thing because you get paid to run it. But you have to bid into a market. And if I'm bidding natural gas electricity versus free solar, it's hard to win those bids. And so these big fossil fuel plants shut down or coast way down in output while the sun is shining, particularly when there's a lot of solar in an area. This is Australia, very high solar penetration compared to what we have even here in New England or California, right? However, as the sun goes down, these plants now have to come back up and start filling in. As you know, every kilowatt hour we use is being generated live, right? With some tweaking and variation, right? So whatever we're using is also being generated. It's one for one, right? But as the sun goes down, the power plants have to come up, and they have to ramp up fairly quickly, and that's hard to do with some of these larger generating facilities, either coal, natural gas, whatever, right? So batteries play an important role in these environments because they can come up to power quite quickly, almost immediately, right? They become cost effective. And then the other cool thing about them is if you have excess solar production during the day, you can charge the battery and prepare it for that period in the afternoon when the sun starts going down, right? Another driver for batteries, grid capacity. This is something we're already seeing here in New England. How many of you have thermostats in the Connected Solutions program? Anybody? One. Well, good for you. Cool. All right. You get a really hot, humid afternoon. Think late July, early August, right? Everybody's cranking up their air conditioning. They're coming home from work, so there's office buildings still running, and now the houses air conditioners are coming up. The utilities will say out loud, batteries help the environment because we don't have to start up those dirty peaker power plants, namely diesel generators, and they're really dirty. So they don't have to start those up because the batteries help offset that. What they don't quite say so loudly is that in some parts of our grid here in Massachusetts, during those events, those grids are running damn near, if not over capacity. A major switching yard, let's say downtown Salem, there's this big switching yard, all kinds of transformers and everything, serves most of the city. One of those transformers blows up because it got too hot. Suddenly you've got thousands and thousands of people without power, and transformers have a huge lead time to get them replaced. So they're gonna scramble to get a transformer to bring that city back up, right? Well, batteries play a role because when the power goes out, when the power load goes up, the utilities have a program where they'll say, hey, can I use your battery? It'll help reduce some of the grid load. It's called the Connected Solutions Program. There's two forms of it. One of them is a thermostat. If you're a National Grid or Eversource and you get a thermostat from them and you enroll in their Connected Solutions Program, during this peak event, and this has happened to me, they will, let's say it's a Thursday afternoon, and around 1 o'clock, they'll take my air conditioner and turn it down, make my place colder. Then at 3 o'clock, they turn off my air conditioner and they stop they stop the load that my air conditioner draws. So basically, they've made my house into a little refrigerator, and then from 3 till 6, I ride out without an air conditioner. First time it happened to me, I couldn't understand why my place was getting so cold. And I walked by my thermostat and I said, we are now in a demand response event. And that's what they're doing, is they were dialing back demand. And the same thing happens with the battery. During the demand response event, they switch your battery so it's gonna export, gonna produce power. Most people keep their batteries in what's called an emergency backup mode, but you allow the utility to switch it into this export mode, and it shaves demand off the grid and reduces some of the load on the major components that could potentially overheat. So that's a big deal, and if you get enough small batteries distributed around the grid, you can really do knock down the grid load. And on top of all that, if you have a battery and you opt into this program, the utility pays you. It doesn't pay for the whole battery, but it's a nice chunk of change to help offset the cost of the battery. A typical 10 kilowatt hour battery might generate $5,000 in income spread out over 5 years, so about $1,000 a year. Right? So it's not an insignificant amount of money, and that's one of the other reasons people like them, because now I've got an emergency backup battery, and I get paid occasionally when, during these demand response events in July and August. Okay, so that's called the Connected Solutions Program. So that's a pretty big incentive. Another thing that's driving the battery space is new products. Prior to electric cars, lithium-ion batteries were pretty expensive. We can thank the folks at Tesla for rolling out electric cars, but also dramatically impacting the costs associated with building these batteries, right? And then on top of that, Tesla introduced the Powerwall. I'm sure you've all seen these. They started around 2015. And within a couple of years, there were dozens of companies making them. You've probably seen them: Enphase, Pika, now Generac, Sonnen, LG, Franklin, Panasonic, and they just keep coming. There's new manufacturers knocking on my door all the time. They want me to sell their products, right? They're a larger operating range, longer life, higher power density, so they take less space. There's no off-gassing. They're lighter, smaller, more reliable. All kinds of things that Chris talked about that we look for in batteries, right? And because there was so much solar out there, clean charging of these batteries became, oh, okay, just plug it in and it charges from the solar. And that's how they work most of the time. In fact, the batteries by default are solar charged. Some of them, I know the one I have, can be switched where I can grid charge it. So for example, if you told me, hey Mark, we're gonna get a foot of snow tomorrow, I would switch my battery into backup mode, and it would fully charge from the grid and then be ready if the power went out. Okay. The basic chemistries that we're dealing with nowadays, this nickel manganese cobalt, which is the most common battery they use in cars. As Chris said, they're little cells. Panasonic's big manufacturer. They're a little bit bigger than a AA battery. And there's thousands of them in the car. Pretty lightweight, high power density. And there's a number of home batteries that use the same NMC chemistry. Lithium iron phosphate is sort of the next iteration. It's a little bit heavier than NMC. It ignites at a higher temperature, so that should make it more attractive from a fire standpoint. One downside is if it gets really cold, you can't charge them because then the metals start plating out. But it is becoming the most common home battery, and it's starting to work its way into cars. So most of the batteries we're working with nowadays are lithium iron phosphate chemistry. We're still doing some NMCs, but even those manufacturers are switching over to lithium iron phosphate. I get asked a lot about battery recycling. I mean, we see horror stories, right? You'll see a fire at a recycling center because of a battery, right? I'm thinking a vape battery or an old bicycle battery or a scooter battery, right? The batteries that we have in our garages now, if we're doing one of these, or if any electric cars in the room? Am I the only two electric car driver? Whew. Okay, guys, got to catch up here. There's going to be a huge market for recycling. Because the metals are so valuable, I expect battery company recyclers will be competing for end-of-life batteries to get the raw materials so they can make a business out of them. There's at least one company out there that takes the old Nissan Leaf batteries and combines them into utility scale batteries. It's pretty cool, actually. And then, what's the likelihood of them getting recycled? If we look at the lead acid experience, 99% of lead acid batteries nowadays are recycled. You all know that if you found an old lead acid battery in your garage, take it to an auto parts store, they'll give you $10 for it, the core charge. Doesn't matter where it came from, how dirty it is, they'll give you $10 for it. And that's part of the way you get these things back, is you provide a little incentive for them, right? Battery fires, I think we've already made this distinction, but I'll make it again. The solar batteries are not the same thing that's going into these scooters and e-bikes and vape pens and everything. It's a very different experience in terms of what these batteries get tested. There's only one UL standard for a scooter battery. It talks about system safety for e-mobility. Meanwhile, home batteries, UL 1642, UL 1973, UL 9540, plus the 9540A destructive testing, right, where they basically start a fire to see if it will go into thermal runaway. And within 9540, there are 32 different tests that they do on a battery, including collision tests, impact tests, right? So it's a pretty robust set of tests. And it has to be, right? I mean, to go into a house, you want to make sure that this product's been tested. It's kind of scary, on the other hand, with these scooter batteries and e-bike batteries. And if you've been to New York City, all of the delivery people use these. And the New York Times had an article a few months ago about 17 people have been killed by e-bike batteries, where people charge them indoors or irregularly, or they overcharge them or whatever. They mix match chargers with the batteries. None of that can happen with these home batteries because it's an integrated system. The charging is there, it monitors the control, it keeps the battery in the optimal charge range. Just like with a car, it's very hard to screw up charging on a home battery, right? The 9540A testing is they basically turn off all the control systems in the battery. They heat one cell up, and they basically get that to try to burn. The cell will eventually explode. It's designed to do that. And then the test is, okay, will that little explosion cause the cell next to it to burn, or the cell next to that one to burn, or whatever? So what they're trying to do is create a thermal runaway condition. Right? And as Chris said, it's not a pass-fail. It's more like, how far did we have to go to make this thing catch fire? Typical batteries, when we do them in a house, between 10 and 20 kilowatt hours of storage. Keep in mind, a typical house uses 10,000 kilowatt hours a year, which is about 27 kilowatt hours a day. So if you've only got 20 kilowatt hours in storage, you can't live like you live when you're connected to the grid. All right? You have to change your behavior. You can't do laundry, for example. An electric dryer would chew up a battery in a couple hours, right? The batteries that we're using right now, and I mean, who knows what this will be 3 months from now, but right now we're using a lot of N-phase batteries. You've probably all seen them, 5 kilowatt hour units, and we use a LG battery. It's a 14.4 kilowatt hour unit. The N-phase is lithium iron phosphate. It's only compatible with newer N-phase microinverters. The LG is currently NMC, but will be transitioning to LFP. It can be integrated into any solar system. So not only are you going to see batteries going in with new solar systems, you're going to see retrofits. I got a solar inverter I put in 12 years ago made by a company called Selectria. Can you make a battery work with that? The answer is yes. The way these all work is string inverters, the old inverters are all designed to work within the 60 cycle to match utility grid frequency. What happens is the output of the solar feeds the battery has its own inverter in it, It converts the AC from the solar to DC to charge the battery, and if the battery gets near peak, then the inverter in the battery says, oh, I'll just tweak the frequency, and it throws it out of spec. So it changes it from 60 cycle to 55 cycles. The regular inverter says, oh, 55 cycle, oh, the grid's out of spec, and it shuts down. And then when the battery gets discharged, it sets the frequency back up to 60. The solar inverter says, oh, the grid's back, okay, and it does its thing. Right? And that's built into the inverters. So the inverters are all designed to operate at 60 cycle. When you go out of spec, they shut off. And that battery is smart enough to fool the grid inverter to do that. Pretty clever, pretty simple, right? As I alluded to before, these are not typically a whole house solution. For example, too much load and they will trip off. When we put the battery in my house, this is now coming up on 2 years ago, I got one as a beta site from LG. The battery, I did it as a whole house, okay? And that was fine. Then I got an electric car about a year later. And we had a power outage while my car was charging. And so the battery turned on, that was fine. The car charger shut off, and then it did its self-test, and it came up, and the car charger is like 12,000 watts. You know, it's a 50 amp circuit. And as soon as I got up to the 12,000 watts, the battery went and shut off. So too much, my battery can handle about 7,500 watts of load, right? The other thing is you want to avoid the large loads. Electric dryers, clearly. Electric water heaters are a problem. Typically, when we do what we call a protected loads panel, it's heating, refrigeration, lights and outlets in the kitchen, water pumps, sump pumps, internet, television. Those are the things you typically power, right? And level 2 car chargers, unless you've got a room full of batteries, you're not going to be able to charge your car off of it. My car battery, 82 kilowatt hours of storage. The battery on the wall in my garage, 14.5 kilowatt hours of storage, right? So you can imagine, it would be enough charge to get me to a good charging station, right? Cold batteries lose capacity. So for example, I can show my battery at 100%, it's in the garage, and then at night it drops to, let's say, 10 degrees outside. My garage will drop to maybe the high 20s, low 30s. And the battery's 100% when I went to bed. I get up in the morning and it says my battery's at 90%. So I'm losing a big chunk of capacity just because the battery's getting colder. And it's always recalculating its capacity, right? So cold installations are a little bit of a problem. I don't know if the manufacturers have heard it from me, but I'm certain they've heard it, that they need to find a way to keep the batteries warm. Car manufacturers already do it, right? Part of the reason your electric car mileage drops in the winter is because some of the energy in the car battery is being used to heat the battery, right? And that's what these battery, home battery guys have to figure out. The more we put these in garages and outside, frankly, I like doing them in garages and outside. They're easier to install because I don't have to build a closet for them. The more they're gonna have to solve this cold battery problem, right? And then because you only got 20 kilowatt hours or 15 kilowatt hours of storage, you have to, as the homeowner, understand the limitations and your behavior, right? It's funny, one of my sons lives with me, and he's pretty tech savvy. Power goes out, and we pull up the app. LG has a nice little app for looking at the battery status and everything, and we say, oh, the house is drawing 500 watts. What can we go shut off? And we start going around the house unplugging the phantom loads, the little transformers, everything that can draw electricity. Oh, we're down to 300 watts. Okay, now we can run for a week. I joke, it may not be a week, but batteries run in 3 basic modes. The obvious one is emergency backup, right? And then you power those selected loads that you want to power during the outage. There is also something called self-consumption. This is, I generate energy during the day on my solar system. I store it in the battery rather than spin it out to the grid. And then later in the day, as the sun goes down and my solar stops producing, I start running the house off the battery until the battery is drained to some set level. And then the whole thing starts over again the next day, right? This turns out to be a good thing where I live in Hudson Light and Power because they don't pay me very much for power that I export. So instead of exporting it to them, I put it in my battery. And then there's something called time of use, which we don't see a lot of yet in Massachusetts, but it's coming. And this is particularly big in California, but in the afternoons, the electric rates go up substantially. So people store solar generation during the day, and they run off their battery after the sun goes down, so they don't have to buy the expensive electric rates. The one time of use rate that we're dealing with right now is in Groton. It's a municipal utility, and their regular cost for electricity, this is not the delivery charge, this is just the electricity, 5 cents a kilowatt hour. That's what their off-peak rate is. But their peak goes from 4 p.m. to 8 p.m., and in the summer, that 5 cents goes to 50 cents. And in the winter, that goes to 43 cents. We put a battery in not too long ago. Customer called me and said, you know, this is the lowest we've had of a bill since they started the time of use rates. So basically, they're doing their whole afternoon running off the battery to avoid the expensive electric rates. So that's another reason. It's not a big financial incentive where I live in Hudson. I get 7 cents when I export versus it costs me 14 cents when I bring it in. But in, once they start time of use rates with Eversource and National Grid, and they are coming, you're going to see even more of these batteries, right? So it's good that we're getting our arms around the code and trying to understand this stuff. One of the biggest challenges for us installing these has been the various interpretations of the code. And I don't blame the people interpreting it, I blame the code. And I'll show you some language in the code in a second that made it really hard to understand what's legal and what's not legal from a code perspective. Batteries must be in a finished space, right? Smoke detectors linked to the rest of the house. We usually, when we're doing one in the house, we build a closet. It's 5/8 type X gypsum drywall. I'll let you guys expand on that. This was not a 1-hour fire room, but I just learned at the beginning of this meeting that when the code edits come out, the next round, it's gonna say 1 hour, and then we have to do what the building code says to get a 1-hour room, right? If you do it in the garage, smoke or heat detector linked to the rest of the house systems. You may need impact protection depending on how low to the floor the battery is. What that impact protection can be is still all over the place. Some AHJs are okay with bolt-in bollards. Others want concrete footings and steel pipes filled with concrete and everything. So we'd love some consistency. I don't care what it is, just pick one and tell me what to do and I will do it, right? I don't want to go to this town and have to do bolt-in and then go to that town, have to do concrete and go to that town to use Jersey barriers. Just tell me what to do and I'll do it, right? And then, what's that? Jersey barriers? Yeah. In the back of the garage, right? Okay, right. And then outdoors, it's got to be at least 3 feet from any door or window, but like in the garage, cold will affect how the batteries perform. You lose some storage capacity when you have outdoor batteries. The good news is battery prices are coming down, so maybe what we lose because of temperature we'll make up for by buying a bigger battery, right? It'll cost me the same. Next year I could buy 25 kilowatt hours of storage for what it cost me to buy 20 right now, and those 5 kilowatt hours will cover the cold temperature losses. I don't know, that may be how things go. That's happened with solar. It used to be I could fit 5 or 6 kilowatts on a roof, and that we'd get what we could get. Nowadays, I can almost double what I can get out of a roof because of the way panels have changed, and suddenly people are buying more than they need because, oh, I don't know where my electric load is going to go. I'm going to get an electric car. I'm going to add heat pumps. Yeah, put in some extra, right? So the code language, I think probably the most important statement in the code, currently NFPA 855, Chapter 15, it says, ESS shall be installed in accordance with the manufacturer's instructions, and they're listed. I have heard stories where there aren't good install manuals. Shame on the manufacturer. So if your installer can't produce an installation manual, then don't let them put it in. Say, hey, I want to see what the manufacturer tells us as far as how it goes in. That was an issue with early Tesla batteries. Now I think they've solved that problem. They got a good manual now, but early on they didn't have a manual. So, in fact, the Generac manual I think was probably the standard. Their manual is really good. In fact, it dictated. It said, like for example, you have to line the walls with Type X. If you had, say, a plywood mounting board, that had to be inside the drywall, and they make that clear in their installation manual. Now, I love pulling this section, 15.6.1.1. If the room or space where the EAS is to be installed is not finished, the walls and ceiling of the room or space shall be protected with not less than 5/8 Type X gypsum board. Anybody want to comment on what's wrong with this language?
I know the answer, so I'm not gonna.
You know the answer, right? It says if it's not finished. What does finish mean? Plywood, drywall, corn husks. I finished my basement with corn husks, right? That's about as flammable an item as you can put on a wall that exists around us, right? So they didn't define what finished meant, right? And that creates all kinds of uncertainty. If you're at AHJ, what do? You go into a basement built in 1950 and it's got the old paneling with little strips down the middle, right? Is that a finished basement? Technically it's finished, but is it a fire safe finished basement? Probably not, right? And so this is why the code language needs some work, and that it's happening, right? The code language is getting tweaked, so which is cool. Again, as I said with the bollards, I don't care. Whatever you do, get me something that I can be consistent with. I'm working in 150 different towns now on a regular basis. If I have 60 projects sold and another 20 or 30 under construction, I'm in 90 different towns. So I'm dealing with 90 different building inspectors and 90 different electrical inspectors and 90 different fire departments. You can imagine the variation drives us crazy. We have a database. Oh, this fire chief wants this. This electrical inspector wants that. This building inspector wants that. It's really challenging for us to try to do a good job and be consistent. So anything that the code can do to eliminate some of that variation would be really powerful. Okay, what are the incentives? If you buy a battery, you get a 30% federal tax credit, whether it's solar charged or not. It used to be it had to be solar charged. They changed that, right? You get to, if you're National Grid or Eversource, you can be in the Connected Solutions program, right? This is where they pay you to use your battery during high demand events, right? The numbers, like I said, a 15 kilowatt hour battery might generate $1,000 a year, maybe a little bit more. If you have not already used the Mass Save loan on your house, you can get a 0% loan up to $25,000 towards the battery, right? If you've done furnaces already in the house or whatever, then you can't reuse the Mass Save loan. Typical installations, here's a Generac, the one on the left. That was done in Sturbridge, I think, but we built a closet. That one looks like they even taped the joints and painted it, so that would meet the emerging code. The one next to it, which is I think in Grafton, this is an LG, that's 14 kilowatt hours, 14 and a half kilowatt hours. That's in a closet. And then this is an N-phase, this is their newer product. Each cabinet is 5 kilowatt hours of storage, so there's 20 kilowatt hours in that closet. You can see the drywall joints have not been taped there. That meets code currently, but from what I hear coming, that would not meet the new code. We ran into a project where we wanted to put it in the garage. Fire chief wanted the bollards as defined in, what's that section, in NFPA section 3, Kristen?
In 855?
In 855, yeah.
Chapter 15.
No, not chapter 15. The bollards defined earlier in the same code book. Chapter 4, thank you. And that code said 15-inch concrete diameter, 15-inch diameter concrete footing, 4-inch steel pipe filled with concrete in the back of the garage. She wanted those, and we had to do 4 of them to protect the battery. We finally said that's just going to take up too much space. The customer did not want to lose that much space, so we went outside. We really didn't have a choice. When we went outside, we said, okay, 3 feet from any door or window. There was no space on the side of the house where we could be more than 3 feet from any door or window. So we had to build a little platform. That platform is a good 3 feet, maybe 4 feet away from the house, and the batteries are outside. Downside is it's going to be a bit cold. If the homeowner so chooses, he could build some sort of a container around insulated cabinet. That's his decision, right? So there's a couple of footings go down a few feet, the frost line, a trench to carry power out to the structure, and the batteries are bolted to the cabinet. And that's pressure treated plywood and all that stuff. So anyways, so that's, I was gonna say living with a battery. I have an LG Home 8. It's 14 kilowatt hours. I installed it in June a couple years ago. It's in an unheated garage. As I said, it's done as a whole house backup. That was a mistake. If I were to do it again, I would do a protected loads panel. It's been a great learning experience. It's a good product too. I use it for emergency backup, though in Hudson Light and Power, we don't have a lot of outages. But I also use it for rate arbitrage, and that is rather than generate electricity that I'm not using, like let's say it's a sunny day and there's no one in the house, anything I generate goes out to the grid. Hudson Light and Power pays me 7 cents for that. Then when I buy it back from them, they charge me 14 cents, which really pisses me off. So when I got the battery, I put in the battery. Now I set the battery so there's always a little bit of room in it. So during the day, anything I generate goes to the battery. And then we're in self-consumption mode, so we come home, we start cooking dinner or whatever, and it draws off the battery instead of drawing from the street. So I'm saving 7 cents a kilowatt hour for a very small amount of electricity, which isn't a very economic thing, but it's a psychological thing. Yes, I see the battery capacity drop when it gets cold. It's life. I'm happy to, in my garage I have the 82 kilowatt hour Volkswagen, the 8 kilowatt hour Prius, and then I have this 15 kilowatt hour battery. So I got a lot of kilowatt hours in my garage at night, a lot of energy in storage, but they're all, you know, UL, whatever, tested, et cetera, et cetera. So, all right, any other questions? Any questions? Yes, sir.
Do you file permits with every fire department when you put a battery in? Could you tell us your?
So I am not directly involved in permitting. More often than not, we certainly do the building permit, and then depending on the town, some of them send us over to the fire department, some of them do them in the building department. So it's not consistent. So and that's part of our database about which towns get what. The batteries always seem to find their way through a fire department inspection. They don't necessarily come through a permit application with the fire department, though. So I saw another hand go up. Yes.
How come no underground vault-type storage for batteries?
I ask the manufacturers. I did get asked an interesting idea. I got asked by one of the battery companies that said, what would you think of a pedestal mount battery not unlike a generator? And I said, sign me up. Because when we can do them outside, I don't have to worry about any of the fire stuff the same. It's not at all a challenge doing them outside compared to doing, but right now I got to build my own platform, right? It'd be neat, like, you know, with a generator, you can buy these concrete pedestals, you put it down on the ground, you put the generator on there, and you're basically done. You dig your trench, run your wires. But I have not seen an underground product yet. So, yes?
This is maybe more of a Paul, with his battery system in the garage, we have to consider 1026, I presume?
Yes, yep. Would have to have working clearance, yep. Yeah,
Oh,
exactly.
you're talking about the 3 feet in front of the, yeah. Yep, no, and that was part of the problem with the bollards in the garage is we needed the 3 foot of clearance, and then the car couldn't fit, right? And so that's why we had to go outside. So, yeah. Any other questions? By the way, anybody wants these slides, I've got to duck out of here at around 11, but you know, if you stop by, I'll give you a business card and I'll mail them to you when you email me. Yes, sir.
When you're installing a finished basement,
Not according to the code, no. If you were using the old lead acid batteries, then yeah, you would have to deal with the hydrogen. But these are all sealed batteries, so you don't have to ventilate. The batteries, I've asked the manufacturers about temperature and ventilation, and they're like, it's not an issue. So their overheating testing is pretty robust, so they know that we'll be okay even in a fairly tight space. So at least that's what I've been told, right?
Just one comment, going back to the question of do you need a fire department permit? As of today's code, you absolutely need a permit from the fire department, period. Now, some departments are doing it. I've heard some departments aren't. If it's going through the building department, you still have to get a fire department permit. That's a typical FP6. If there's any problems with that, have them call the state fire marshal's office. We can talk to them about that.
And as I said, I'm not, in my company, I'm pretty far removed from the permitting process. I have a whole crew of people that do permitting. I know we've been getting fire department permits. How we get them, I can't say. So.
Another question?
Talk a lot about battery safety and fires, maybe Chris might be. What is the condition, all of the conditions being on these ESS is secondary to house fire. So we talk about safety of them going to thermal runaway and being contained. What if the
I can't answer, I can give an example of what they do when they're doing the 9540 testing, is that the manufacturer says you can put these cabinets within 12 inches of each other, right? So you could have two battery cabinets, and they will put them closer, and then they'll try and start one burning, see if it not only starts this burning within that cabinet, they put a cheesecloth on the outside of the cabinet to see if that will burn, right? And then, obviously, they want to see what happens to any neighboring batteries. So they do test to some extent for, fire coming outside. Now, I don't know how they test for fire from another source. Maybe you guys can speak to that.
I don't think I've heard of any testing the other way. House fire, battery in it, and then what does it come out of? That's a great question.
But just assuming you have a car fire in a house that we can't put out.
Yeah.
No, it's a great question. I agree. I don't know the answer. I can dig into the 9540 stuff. I have a bunch of it on my computer here. Maybe I'll have an answer by the time Jake and Kristen are done.
So hopefully what should happen by design is that it starts shutting itself off. It should start isolating itself off and reduce its energy to nothing. While they set up, I wanted to pick up the vault. The reason it's not a vault, because it doesn't meet the criteria as an electrical vault. It depends on which definition you want to look at. The building code has a definition for a transformer vault, and then the electrical code has a definition for an electrical vault. The batteries themselves, don't fit the criteria to be the volt. It's usually higher voltages or some other component, like transformer vaults will have an oil cooling, so it's some other hazard that you're trying to separate off. Oh, what I did want to say though, I know we're going to be beaten. I got to leave, but I know Chapter 15 is going to get beat up big, and beat it up. I already made my comments earlier. Send in the public inputs. Again, keep in mind, standard of care. You can't enforce it, I get it, but look ahead. The 2023 is out, you'll see, we modified that. We also included the word non-combustible. Look into nfpa.org/855, free of charge. You can find the document you want, look at the next edition, you'll see for 2026. It's coming up, it's just gonna say non-combustible. We know that there's gaps and it's broken, but it's not necessarily fragmented that severely, but just that's where it's headed. So it's just going to stay non-combustible. And then just keep in mind too, when you open 855, just open it in the front few pages. Get a good look at the people that are there. Everybody on this side has representation. Okay, electrical manufacturers are represented. The industry for PV and batteries is represented, and likely on the fire service side. So even though they're aggrieved from some of the stuff that their own people, agreed to put into code, they should be kind of going up that pipeline and pulling on their pant legs and looking for some code changes, to see, and again, make those public inputs. That's the only way you can make changes. Bye-bye. Good luck.
Thanks, Chris.
You guys, I know what you two were in for.
Let's talk about Chris.
Wait a second, Chris stole all my applause. I want my applause.
Thank you, Mark.
So, if it's okay with you, Paul, how about we take a 10-minute break?
Yeah,
It
perfect.
is 10:34 right now. Let's come back at 10:45.
Anybody who wants my slides, I'm gonna send them to Paul, or if you wanna give me your business card, I can email them to you.
Sam Elliott wants to speak.
And then I'll just let you give the introduction. You want to do that? You can do it. Get her some food. Get her some food.
30, right? But you know what's going to happen is these guys are going to cheat so badly that they're going to stop doing that. All the fire chiefs are going to stop doing so.
Okay, let's get our seats here.
Yeah.
When you start digging into it, we can kind of tell.
Yeah. Well,
Like the commercial requirements for these large material, and then it would be all set, but since they don't say that, yeah, it could be anything.
I got to bail. Hey, Jake, don't take this personally, but I got to leave at 11.
I'm
55, the electrical
last
code.
part of the presentation.
Yeah.
So the second half of the presentation, or this next part, we're going to go divert quickly out of energy storage systems and talk about photovoltaic, because where you're seeing the energy storage is usually connected to the photovoltaic. And then my partner, Kristen, will go out there and finish it up. We're both, Kristen and I, are fire protection engineers with the Massachusetts State Fire Marshal's Office. Kristen's been there 5 years. 5 years. I was there full-time for 23 years. I'm still there part-time. I'm also I'm a full-time career firefighter, fire prevention officer, fire protection engineer with Auburn, Mass Fire. So I have a unique experience working for the state and seeing how the code's done. I also work from the other end, seeing how the codes get enforced, which, one thing I would like to go out there and thank is Westboro for hosting it. This is a great site, and Paul for organizing it. So before we get crucified, I just want to bring out some members that are here. Number one is that Jeff Putnam, he's the state building, Jeff. He's the state building inspector supervisors, so he's on the building code side. And then we have, as long as I can count correctly, 5 members of the Board of Fire Prevention Regulations, including the new chairman. You have Chief Fisher from Merrimack, and then you have Chief Aruda from Dartmouth, District 3. You have Paul Kennedy, and then you have Patty Sheehan. She's the building commissioner of Shrewsbury, and I think there was one more. Okay, so blame them, not me. So we're going to go over photovoltaic and energy storage systems. When this came forward, came up to us. These two subjects have elicited my most or questions going to NFPA saying, "What did you mean?" And are you kidding me? How do we enforce this out there? As Chris said, and of course, you know, he leaves when I go on the attack, is that he made the comment, that's not supposed to be, it's not supposed to happen. Working for the state on the fire side, and as all fire guys know, is we live in a world that's very different, very unique, is that we see what's not supposed to happen every single day. So when you say, oh, it's not supposed to happen like that, well, that's what we have to expect. And so I have a very slanted negative view of certain things. And you'll see why here in a little bit. In our presentation, we're going to split up. Kristen's going to do the energy storage systems, and I'm going to run through the photovoltaic, the photovoltaic arrays on the roofs that we're seeing all over the place. The codes, we have adopted the 21 NFPA 1 with Massachusetts amendments. It was adopted on 12/9/22, and then there was they corrected it as of 2/3/23. That's the one that you want to be using right now. As they said, there is a lot of potential code changes, both for energy the whole code, a whole bunch of code changes coming in, especially with photovoltaic, with Mark at the helm with Chris Towski that's pushing through. There's other stuff on batteries, energy storage system, but we're talking about right now because that hasn't been officially adopted as of yet. The building code, we're in the 9th edition. There is a 10th edition coming out soon. It's a public hearing. It's just finished public hearing. So that's going to be expected out sometime, hopefully summer, early fall, maybe, I'm not sure. We have our fingers crossed and go from there. But we're talking about today. So right off the bat, photovoltaic, PV, okay? Right off, we'll start right out. There's no fire department permit required, period. There's people that go in fire departments that are asking for permits for the installation of photovoltaic. There is no permits, period, required for it. You need a building permit, you need electrical permit, but there is no fire department permit. I sort of equate it like when the building officials get fire department access plans. You have no requirements for fire department access roads. In the building code, what do you do with them? You send them to the building, send it to the fire official for their review, because the fire lane requirements are in the fire code. Same thing for PV. You need a building permit, gets sent to the fire department reviews it and sends it back to you, to the building official. Like I said, building permits and electrical permits are required. We do here in the state side of it, where I had 188 fire departments I dealt with a lot. That was my territory. Kristen had the other side of the state. There are departments that only get electrical permits. There's fire departments that ask for PV permits, but there's no requirement for a fire department permit. There is for a building permit, and there is electrical. And the way you have to think of it is that bell curve. 10% are going to be bad on one side, 10% are going to be bad on the other side. The majority of people are doing it right out there, but no fire department permit is needed. And the building official works in consultation with the fire department on this. The way it happens in Auburn, which I think it works very well, they get the building permit, it goes onto the system, goes into the portal, it comes down to the fire department, we review it, we approve it, we send it back for comments. We send it back to the building official, who sends it out, and that's what it is. It goes to the electrical official in town, he approves it. Building goes out, and fire goes out on every single solar inspection, PV inspection for on final. Really simple, we work well together. Now, I know some communities don't have that. It's difficult sometimes. They don't have a good relationship. You have to have a working relationship. We stress at the state, you have to work with your building official, you have to work with your wiring official. We're in a world today that if you don't, you're gonna suffer the consequences in litigation problems. If there is a problem, if you get questioned or there's an issue on a PV installation, it doesn't go to the building code, it goes to the Board of Fire Prevention Regulations, their appeals board. It goes to the Fire Code Appeals Board. If they're appealing a decision of the fire official in 11.12, enforced by the building official, it goes to the building code, it goes to the Fire Code Appeals Board, not the Building Code Appeals Board. And then if there's any violations, like I said, do it in writing, give it to your building official, and they can set that forth. The Fire Code Appeals Board will not take denials from building officials, just as the Building Code Appeals Board do not take denials from a fire official. Okay? That's just basically the code and the procedure. Now getting into the nitty-gritty with this. We're only going to talk about 1 and 2 family homes because by far that is what we're seeing the most, and it seems to be the most problems with it. The commercial is out there, but it's not as prevalent as the 1 and 2 family. The real reason that they have requirements in 11.12 is so that the fire service can get up to the roof, to access the roof, to ventilate it. Real simple, that is the picture right there. That's why the fire service needs these requirements. Now, I was talking with Tesla, Tesla's expert, and Tesla's expert came out and said, you guys shouldn't be on the roofs because it's dangerous. So that's an old, the ventilation, the vertical ventilation, that's old school. You shouldn't be doing this. This should be, other types of ventilation. And it bothers me that this person said it. It bothers me to no end because they're dictating how the fire service is going to fight that fire. And is it this no vertical ventilation? Is that a mandate by the United States Fire Administration? Is that a mandate by NFPA? No, no, no. And if you don't ventilate the house, are you going to get sued for not doing it? So I try to be nice and tell them, yeah, that's California. That's done a little bit differently. Vertical ventilation is needed. We're going to do it. We want these access pathways. We need to get up to the roof. For emergency egress or emergency access to a window, potentially, and we need to ventilate it. Real simple. And right off the bat is the big one that we see is the building-mounted PV. There is the integrated ones that you're going to start seeing more and more of. I don't know of any ones around here where they're using the roof is actually is the PV. Tesla has some. You do it down in Mendon? Upton, sorry. I'm thinking Upton. You do have some in Mendon? Sorry, in Upton. Jeez, I got back, Chief.
One, and we're going on, I think, a third.
If in a longer presentation, we had some pictures of what they actually look at. It's kind of neat looking to see. Is it Tesla, Chief? Tesla. Okay. The other ones were not Tesla, where they're big sheets. There's different exceptions, but because they're so unique, except for you two, we're just going to deal with the building-mounted ones. The access pathways, this is all in the fire code. If you look at the section out of NFPA, it's one page, really. That's all the requirements for 1 and 2 family homes. In the amount of questions that stem from this one page is unbelievable. So access pathways. This is just a pathway so the fire service can get up to the top of the roof to ventilate or to get to emergency access to a window. You need 2 pathways, at least 36 inches, going from the gutter to the ridge. And one of them has to be street side. They don't have to be on, the question came up, did they have to be on every single roof plane that there is a panel, a PV array? That is no. No, you can do it adjacent, or you could do the other side. So as long as you're looking at two, that's what we're looking at, and we'll have some examples here. You're supposed to have minimal obstructions. Now, what is a minimal obstructions? A vent pipe, conduit, and mechanical equipment. That's what NFPA says, and that becomes a problem, because we ran into, right off the bat, if you put a piece of conduit going across the roof, across the access pathway, we're not going to be able to get our roof ladders up there. We can't slide them up there because you run into the obstruction. Or the next thing is, as you're running it up there and you can hook the ridge, we have roof hooks, we hook the ridge. Now you're on a teeter-totter. We'll get into it a little bit more. That becomes a problem for the fire service. And once we start to bring it up, the industry kind of agrees with it. But when we talk about minimal obstruction, it's really minimal. I don't have a problem with the conduit going across in the ridge, because you're kind of creeping across. Where you need a roof ladder, we don't allow conduit. And I'll get into it in a little bit. The next thing is setbacks. First is the access path. The next thing is the setback. So at the ridge, you have a selection depending on how much of the roof plane is covered. If it's less than 33%, if it's 33% or less, it's 18 inches on either side of the ridge. And then if it's over 33%, then you talk about a 36-inch setback. And this is what you're looking at right there. This right here, you see, in this case, they show, on this example, you have two access pathways that form the vertical H, and then going across is the setbacks from the ridge. Now, on this house, I can tell you the bottom left-hand side, I rejected that plan right there, is because that's coming down at an angle. That access pathway did not come down to a gutter. It came down on an angle, a crotch of the roof. There's no way we can get our roof ladders up into there. And that ended up being rejected. But this is what you're looking at for a photovoltaic system. One thing that I ask that's popped up when we do reviews in Auburn as the AHJ is that we want them to show us all the setbacks, and we want them to show us all of the access pathways, whether there's panels on the roof or not. Because what I've found and what I've heard throughout the state is that solar industry, like the battery industry, just puts it up anywhere they want. Their plans are awful. They come in there and then they go out to the house and they just put it anywhere in the house. So I want the setbacks, I want the ridge, and I don't care if they move these around.
We're not all awful, Jake.
Have you come to Auburn? I haven't seen you. It is a problem. It's just that they change that out, and as long as what I tell them, as long as they don't go into that shaded area, I don't care. You might have to go back to the electrical official and adjust your things. If you talk to the former commissioner and some of the building officials that when we've given this presentation before, you're hearing them, they want stamp drawings of as-builts, because they change it all around. But this is what I'm looking for. Now, they could have come across and only put 2 access pathways and I would have approved it. But now you give it to me, I approve it in writing, and as long as you don't touch those aspects, I don't care. If you have a sprinklered home, the requirements go up to 66%. That's highly unusual, but there is something. Now, this is something that gets caught off guard, it's missed. I don't understand why it's missed, is the emergency access path underneath a emergency escape window. So in both pictures, those are emergency escape windows. The one on the left, that was not shown well. The dormer was not shown well on the drawing. We approved it, we went out there, and they're going right out onto a panel. They can't do that. That got rejected. They had to modify that and put a 36-inch channel or an access path down that. The one on the right, you've got two windows. One's the bathroom window. The other one is the bedroom window. That's the only bedroom window. That's an emergency escape window. And you see right below it, there's 4 panels. I didn't miss that one. I got that one. I made sure that was clear. Those 4 panels were supposed to be on top of the roof, on the upper roof, and they moved them. And this is one of the problems that we have. If you have the building integrated systems, you are allowed to modify that, Chief. So if you have the Tesla shingles, you're allowed to modify that, right in the code right there. The next thing, which is being debated, I think the decision was made, or there's an interpretation coming out. There's a requirement that the installer puts the document, their emergency, a number, a telephone number there. I believe what's going to be coming out of the board is that this is a non-emergency number. I've always interpreted it that at 3 o'clock in the morning or there's something wrong, why do we have to wait to 8 to 4? And then what happens if it's a holiday weekend? My interpretation and my understanding of it was always an emergency contact. If Friday afternoon there's a fire on a long holiday weekend, who can we call to go out there and say, what are we doing with your system? How are we going to deal with it? But the board's going out there, to their credit, in adjusting it and coming out. Is that an interpretation, Chief? So they're going to modify it. There's a proposal to modify it to remove emergency. Like Mark.
Part of the reason is all these new systems have rapid shutdown. If that lever has been thrown, that system is deactivated. All the wires are deactivated. So there isn't anything else that I could do if I showed up at 3 in the morning, other than to say, is the rapid shutdown switch shut off? That's all I can tell you to do, right?
The concern as the fire guy is that at 3 o'clock in the morning, I'm not the expert on these systems, and I want it. But anyways, that's neither here nor there. The board's addressing it. So this right here is a basic system that you have. Let me get to you later. A typical house, you've got the setbacks at the ridge, and then you have your access pathways going up. And then you see the dormer emergency escape window, you've got 3 feet below it, okay? So this is where we start to get into the problems, is that in the NFPA codes, it talks about detached structures. Detached structures are not required to provide roof access. Non-habitable. Okay, what's a non-habitable structure? And they give examples like parking shade structures, carports, solar trellises, and similar structures. Well, I had to look at this. All of these are, for the most part, they have no walls. For the most part, they're all open. So there's no requirements, there's not going to be a fire. The problem is that what's being implemented is these. Is that you've got a garage there. A garage right there, that's what stemmed it. That's got space above it, Mantown, and space behind it. That's detached. That's non-habitable. Habitable means people living there. So which I went back to the company and said habitable. And they said, yeah, it's not habitable. Well, habitable, I mean, by definition, nobody's living there. Schools, office buildings, fire stations, you name it, town halls, are all places that are non-habitable. So if office warehouses, oh, now you move. See, look, now industry runs, no, just kidding. A warehouse is non-habitable. Are you telling me that there's no requirements for solar, for PV arrays on a warehouse because there's no definition? So we went to NFPA and we got an interpretation from NFPA, what it's intended to mean. It's not occupiable. People aren't there, congregating there, doing things in there. So you look at this right there, that T there, that's a horse barn. With the tack room, They have an education room where the kids come in and there's a riding arena. It's a big, big building. That would be required to have the setbacks. And you as the authority having jurisdiction, the AHJ, you're allowed to have them meet the residential code, residential requirements as opposed to the commercial. The other one is that two-story garage. Oh, that's non-habitable. Well, that person right there, upstairs, has a man-town, has an office, has a bathroom, has a little kitchenette, no sleeping quarters. How is that, what's the difference between that and a regular home? So on something like that, the way that we've been interpreted and what has been backed up by an NFPA definition is occupiable. In all these cases, those are occupiable. People are in there a period of time, other than dropping your car and leaving it. We've been instructing the fire departments to treat that and require PV to meet the setbacks and access pathways to that for a home. And that's the statement that they confirmed. It's occupiable. Okay. The access paths. The fire department in 11.12 has the ability to modify the requirements based on their ventilation procedures. And I'll show you in a little bit why I bring that up, because there's certain things that we've gone out there and suggest to fire departments to pull the trigger and say, your ventilation techniques need this. I'm requiring a little bit extra, and we'll get there in a minute. So what will happen, so the question comes up on that one, is that how does that get cited? So the building official sends the review to the fire department. The fire department provides comments back to the building official. So the fire department would go out and cite 11.12.3.1 and state his thing. So on this case, where I use it quite often is we do not allow any perpendicular conduit on an access pathway. So I would say I would reject the plan. I wouldn't reject the plan just for that, but I would make a comment that there shall be no conduit in an access pathway per 11.12.3.1. So the building official. So we would go send that to the building official. The building official would send that to the opponent or the appellant. It would go to the Fire Code Appeals Board. So again, it's the same thing. It's the same thing with that on a fire lane. If they were to put a building permit in for a brand new building, and they have a fire lane, and the fire chief said it has to be 20 feet, and they went to appeal it, who do they appeal it? Same procedure. You send it back to the building official. The building official is enforcing the requirements of the fire code.
Well, so just, I guess, a clarification on that, so. Yeah, no, and I think I understand where you're going, but the fire official ultimately, because the requirements currently reside in the fire code, the fire official needs to determine compliance with those requirements. The building official is the permitting authority. So Jake, I guess, would the Fire Prevention Regulation Appeals Board accept a violation letter from the building official, or do they expect that to have to come from the fire official in order for them to move forward with an appeal?
It would have to be ultimately coming from the fire official. Well, so the Building Code Appeals Board does not hear this, because this is a fire code, and the fire official is the one enforcing this requirement. This is not a building official issue, because they're enforcing it through the fire code, just like the fire lanes. You know, that's the thing that, we've had fire lane requirements in the fire code forever. It's been in the building code, there's no issue with that. What is the issue between that and this? Same thing, same theory. But that is, the appeals go through the Fire Code Appeals Board. I don't know of any, do you know of any appeals on solar? Chief? I don't think there's been one. I know there's been on energy storage, but that's different. No, but solar, no. Sure. That has popped up from the start, and that is the guidance we've been given through that. I missed that, Jeff.
So fire officials can cite any code reference in the fire code. They can cite that, they can send a violation letter to anyone for any reason, whether there's a permit requirement attached to that or not. And then that can be appealed through the Fire Prevention Regulation Appeals Board for any section in the fire code. I do understand how then it is confusing in terms of, is the building official supposed to hold up the building permit over this and wait for that decision? Are they supposed to just act on the building permit in regards to the requirements in their own code? That is...
On that, that's a violation, just like you can't issue a building permit if you have a gas permit, a gas issue or electrical violation. Same thing with that, Jeff. Yeah, so that's something that has not come up as an issue, and deal with that when it comes, I guess. So let me what was that? That is not, the question is, will they allow the fire department to permit solar? That is a question for both boards. Will the BBRS allow it, the BFBR to regulate it, to permit it? And then the question is, would the board want it to permit it, the BFPR? So we'll continue on. I'm not going to get into that because that's well far past. So what is a fire department looking for when they go out there and receive a permit from the building official? What are you looking for? So this is one that gets sent in. So what are you looking for? So on this one, how do you go out there and tell where's the access pathways? Where are the panels? Where's the ridge setbacks? What are they? Where is the ridge? Is there a ridge? So we're looking for those two 36-inch pathways, one on the street side or the street or driveway side, and having no obstructions. And then the setback from the roof. Now on that one, it's kind of difficult. What's the percentage? What's the distances? How do you deal with that? So take a look at this one. This is another one that's out there. So if you take a look right in the top left corner, it says green dotted lines indicate 18 plus 18 ridge. So either side of the ridge, they have 18 inches. That's great. But if you look on the other side, the percentage of solar coverage is 43%. It's supposed to be 36 inches. So in this case, the fire official should notify the building official of a violation of the code, saying it should be 36 inches on either side of the ridge. Now, what are we looking for with the access pathways? We saw the overhead. Okay, there's two access pathways. This is where there is a tremendous disconnect out there with industry and industry in the fire service. We talk to fire service, and we give this presentation, we're telling them you should be looking at Google Earth on every single one, and then Google Street View, to look at where these access pathways, are they gonna be accessible? On both of these cases, both of these houses, they're being put up, the access pathway right where the lines are crossing. So there's no way the fire service can put up their ladder and access that pathway without coming in contact with the electrical lines. That's a big issue. With that, you take a look at this. Here's one on the left-hand side. You'll see the line on the left side. You see a little pathway. That's the access pathway. How is the fire service going to access the ridge going up that without coming in contact? In all of those three scenarios right there, we would suggest that the fire department reject it, using that 11.12.3.1, saying that your fire department's operations will not be able to access that. If you look at the one on the right, that's a single-family home. The electrical line goes across the access pathways. The access pathways we have the beamer here, on the left-hand side goes up and over. How does a fire department get up there on that roof without touching those electrical lines? That becomes a problem. The next thing is this. Here's an access pathway right where that yellow line is. What's right there? How do you put up a ladder with that tree right there? Now, it turns out that one, the tree is supposed to be coming down, but that's something you have to go out there and sight. Unlike on the right-hand side, the access pathway on the right-hand side, there's an electrical line there coming in, and you see the bushes and the trees. That becomes a problem. That's what the fire service has to go out there and look at to make sure. We asked them to do it prior because there's a big complaints from the industry saying, why are you telling us last minute? Everything's installed. Now you're telling us that we can't do that? We're telling people to do that, the fire departments to do it early and often. Here's two more examples. The one on the left, you see the bush. How are you going to put up a ladder there? You can't. And the bush is going to grow and there's going to be problems. The one on the right-hand side, that's the one that we showed you before. And they want us to access that roof right at that valley coming down, the pointed valley. How are we going to do that? Becomes a big problem. That's the things that you'd be looking at, the fire department should be looking at, seeing, noticing it, and sending that back before they install it and say, hey, listen, it's not gonna work. They did have another access path. They actually moved it to the right-hand side of the right picture, okay? Another question when we review these is what is meant by on either side of the ridge? On either side of the ridge, we had to go, Kristen actually went to NFPA, and they mean both sides of the ridge, not either or. By definition, either is both. So when you have the 18-inch setback, it's supposed to be, or the 36, it's supposed to be on either side, both sides of the ridge. And then the next thing is popped up, and I don't understand how they wrote this and put this out, whether it was NFPA or the IFC, because they're identical. How do you measure the planned roof area of the building? It says that when we talk to NFPA, we call them and ask them, it should be a bird's eye view. You're looking down at it, at the roof. So you're not taking into account the angles or anything like that. It should be for the whole building, the whole roof plane. You don't count each roof as a separate roof plane. So you have a house like that, a plan come in like that, you're looking straight down at it, two-dimensional. And that's your measurements. The highlighted part is where the panels are. And it's real simple. You take a square footage of the whole building and then you calculate all the arrays, and that will give you your percentage. One thing that we stress to the fire departments, if you have it close, There's a lot of 32.7s out there. 33 is the magical number. 32.7 I see quite frequently. I don't know why 32.7. I would be a little bit less obvious. I would maybe make it 28. We usually sell the fire departments, if it's around 28, measure it. And you can go on to Bluebeam or you can go on to a PDF reader and just measure it out. It doesn't matter on the scale, it's a percentage. So it doesn't matter if it's 1/16 scale or a 1/4 inch scale. It's a percentage and that's what comes up. And that's how you go out there and determine or confirm they are correct or not. After doing it a while, you can tell 33% pretty quickly. Like I said, that is just a simple calculation. It has nothing to do with square foot or anything like that. It's all a percentage. Now, another question is, how do you measure that 36 or 18-inch setback? You just found out, you did the calculation that it's 43%, they need a 36. That is measured down the plane of the roof. So now we were talking 2-dimensional, now we're measuring 3-dimensional. You're going from the ridge, measuring down 3 feet. That is another interpretation that we called NFPA and asked them for guidance on. What do you mean? Is it 2-dimensional or is it 3-dimensional? Okay? Now, a big problem here is what do you do with hips and valleys? If you look at NFPA, NFPA shows you in the back of the book some examples. We went to NFPA on this one as well. And best as we can tell, these requirements came out of California where they had low slope roofs. Because they show you on a building like this, you can use an access pathway running up a ridge or a valley. That's great for a low slope. But what happens if you have a steep slope? How do you deal with that? And this is where we use that, hold on a second. So on this one, I skipped a whole bunch of stuff. So IRC and NFPA both say that. If you look at the history of it, it looks like it's coming from California. NFPA in the fire services is taught if you're working on roofs more than 412, you should be on a roof ladder or on a some type of aerial device. So 412. So what we do in Auburn and what we recommend is that if you have a pitch greater than 412, you cannot use a hip or a valley to access the roof. And I'll just give you a couple examples. You tell me that White House right there, you're going to climb up that ridge. Climb up to the ridge using on one side of a hip. You can't do that. I don't understand how this got through NFPA. This is something that the industry kind of agrees with us. You take a look at the bottom picture, that's low slope, that's less than 412. You can climb up that, that's not a big deal. You can climb right up that valley, that's not a concern. But if you look at those two houses, fire service can't do it. For you non-fire service people, we're using roof ladders to hook the ridge to get up there. How do you do it on an angle? You can't. That's something I think that NFPA really missed. Going back to conduit. Can you have conduit in the access pathways? By NFPA, it says that you can have minimal obstructions. Is that a minimal obstruction right there? That a conduit going across the roof. Kind of minimal, but this is a small house. It's not high up. You can probably push the roof ladder over there. But what will happen, if it's higher or lower, you're going to create a teeter-totter effect. You're going to have your roof ladder go up, depending on where it is. The hooks might not be able to hook the ridge, or might push it up higher, so it's not hooking the ridge, it's hooking the ridge vent, which you don't want to be on that. Or if it's down lower, you're going to be teetering-tottering. You're on the lower part. When you put your weight on, it's going to pop it off. It's one of the things, that's another thing that we use, 11.12.3.1, is saying that your operations say, no, we're not going to allow conduit in there. Some of the bigger companies out there have stopped putting conduit in the access pathways. We've had good success, at least having conversations with Mark and his crew about that. This is going back to the comment about, I personally like, and we recommend to the fire service, you show us your access pathways, your setbacks, and then you do whatever you do. Because on both of these situations here, they were installed, that didn't meet the plan. So now they had to go resubmit the plan. On the right-hand side, the access pathway, you see the conduit coming down. Not only does it go across, it comes down. There's no way we're going to access that. That becomes a big problem out there. More with the building officials. I'm not too sure if, Tom, do you get hung up on that? When you have panels, they change the panels, the array, where the panels are? Okay. It's just one of those issues out there that is a concern for us, because on this one, our roof access has changed. This is now becoming a problem that we're hearing more and more about this. What happens if you put existing panels up and then you take them off? You put them, you have an existing roof with panels and you add panels. So on this one, you see the bottom ones are existing PV, they're adding new ones. The new ones have to comply with code, with 11.12. There's no retrofit requirement to have the existing meet it. So if the existing ones were put in and they were 12 inches down the ridge and they're supposed to be 36, they're allowed to stay. Now, this is the problem right here. The problem is we're seeing throughout the state is these panels are coming off the houses. They have to re-roof. As long as they have an existing panels, whether they were installed before the code requirements come, they take them off and they put them back up on that same roof, same panels, that's perfectly fine. There's no issue with that. What we're seeing and what I'm hearing is that you're having panels come off the roof, an addition goes in, and they put them on the addition. You can't do that. That they have to comply with code. Or they take them from the north side and they move them to the south side. Can't do it. They would have to meet new code. If they want to upgrade the panels, so they're using more power, they change out the panels, then that requires coming up to current code. So in a nutshell, that's PV. Up next is energy storage systems, but you had a question, you had a couple questions, sorry. Yep, the ridge. Oh, so I believe that, so you're talking about the conduit? So the question is, why doesn't the board go out there and make a requirement that no conduit be in the access pathways, correct? I believe that the board is taking that in, and I believe that's something that's coming through, correct, Chief? So they've already done that. The problem is, you know, when Mark, and of course they're not here, when Mark and Chris are talking about this, something was thrown in my face, is that you as the enforcers are the problem. Building and fire officials were the problem. And I had said, time out. Whoa, no. It's not us, it's the code. The code's the problem. When it says there should be no minimal obstructions are allowed, how is that conduit going across? That's an NFPA, that's an IFC thing. It's them, and it's how it gets enforced. And you know, Chris and Mark talked about technology and the NFPA. You realize that when you make a change, you want to make a change in NFPA, it's not done tomorrow. It's done 5 years from now, if it is. That's a lot of PV panels that are put in. And the thing is, technology is pushing so far ahead, especially with energy storage. Things are changing left and right. It's very difficult. We're caught behind on all of this, on the PV and on the energy storage. We're learning on the fly. And that's problematic. Yep. So on that, the question came up is that, are you a wiring official? Okay, so a wiring official goes out, last one out to see a PV installation, notices conduit across an access pathway. So our answer, what we're out there telling the fire departments is to cite it right off the bat. On every single review that I do, the fire departments that I deal with, I tell them to put that comment in there. No conduit should go across the pathway. So they know up front, okay? If it goes out there, they were notified and they put conduit out there, too bad, so sad, they're gonna have to do it. What the problem I have is that if you don't say anything and they do it and then you go out and you see it, it's kind of too late for them. So, so the question is, do you sign off, does a wiring official sign off if there's conduit going across it? That's a fire chief decision. The fire chief would go out there and say that does or does not comply. Again, when the fire chief does that, I would suggest that he tells it right up front. We don't want to be out there after the fact because that helps no one. When we did this presentation, this became a big issue. We said, no, don't do that. Yep, no one's there.
So just a quick backup on that one. As a wire inspector, when we go out for that rough inspection, I'm hoping everybody does that, and they're starting to run the pipe up the house, and you look at it, it's going to go across that pathway. I tell them, you know what? You can't do that. And again, whether or not I have grounds to stand on, they understand why when I tell them that roof ladder that goes up there is going to be a teeter-totter. You can't have it there. You're going to have to come down the front of the house and up under the array or in the house and through the roof. And they go, oh, yeah, we can do that. So there are always different ways to do things. And again, sometimes they all think about it. They're going to do it the easiest way they can to get the job done quickest and least amount of money. But I definitely tell them on the rough that you can't have that pipe across that access pathway.
If you find that, notify your chief, and then the chief can.
What electrical violation follow they violating? That's kind of weird. What's all you guys?
I agree with that, and I will tell you that most of the time, all the time that I've had it happen, they didn't ask for that. I couldn't cite it.
I get it, but that's
Yeah.
what you see day in and day out.
For those asking, oh, sorry. For those asking questions in the audience, this is being virtually remote to about 150 people, and I'm getting emails that they can't hear your questions. They hear the answers, but not the questions. So if you can just please speak louder. Thank
No,
you.
we can repeat the question,
Or
too.
however you want
Yeah.
to do it.
Okay. Okay, sorry.
No, that's right.
Oh, I'm sorry, Charlie.
Oh, I just wanted to have you elaborate on, you're required, you can't fail the electrical inspection, but you can not sign the COC.
That's correct, because they're not going to get the fire sign-off.
So that conduit's in the way, we can just sign off the electrical inspection as passed, but the COC that they want, you don't have to sign it, it's like an occupancy permit.
Yeah, and that is different from our electrical permit as well. That's totally separate piece of paper. So that is true on that one, Charlie. Yep, exactly.
Okay, so I'm Kristen McDonough. Thanks, Jake, for all the info on PV. I'm just going to run through the energy storage system requirements. We are focused today, as you've probably noticed, on the 1 and 2 family requirements specifically for both PV and ESS. The commercial requirements, we would need a lot more time to go through all of those. They're a lot more comprehensive. But if anyone has any questions about those at the end, you can always ask us, or you can also feel free to reach out to us by email. We'll have our contact info up at the end. So just to talk quickly about the energy storage systems jurisdiction, it is a little bit different than photovoltaics in that there is a requirement for a fire department permit. So the fire department does have some, I guess, more direct jurisdiction over these requirements. The regulations are made up of our fire code, 527 CMR 1, Chapter 52, specifically Section 52.9 covers the 1 and 2 family installations. And then that section also references to the 2020 edition of NFPA 855, Chapter 15, which is where the bulk of the requirements actually exist currently. Just a quick note, if anyone was familiar with the June 7th, 2021 memo that was out there floating around for a couple years before we had all of these 1 and 2 family specific requirements in the fire code, that has now been superseded by these requirements. The memo is still posted online. There is going to be like a cover letter added to that soon that will kind of explain that those have been superseded, because we have had some questions about whether that memo still applies. Some of the requirements in that memo and in NFPA 855 were pretty similar, but there are some differences, so just make note of that. As I think Chris had mentioned in his presentation, there is a fire department permit required. Most fire departments right now seem to be using the FP 006 form, which is kind of the standard permit form. Some communities, I think, are developing sort of a more specific energy storage system permit form that asks for a little more specific information on the energy storage systems, but there is no specific statewide form at this point for energy storage system installations. So for permitting, this is one big difference from the previous edition of the fire code and the use of that memo that I was just referring to versus the latest edition of our fire code, is that the permitting threshold for 1 and 2 family energy storage systems has changed. Previously, it was 20 kilowatt hours. Anything under that did not require a fire department permit. Now, we are referencing to Table 1.3 of NFPA 855 as the permitting thresholds that we are using for when a fire department permit is required. And as you can see at the bottom, highlighted specifically is that 1 and 2 family installations are permitted at 1 kilowatt hour. So essentially every single system now will be permitted through the fire department. There's some minimum installation requirements, minimum clearances. There's 3 feet required between units, unless smaller distances are allowed by the manufacturer and supported by their large-scale test results. Just a note on that, that we have noticed that most manufacturers do have listings that allow for smaller spacing than that. Tesla, for instance, actually has basically stackable units, so you've probably seen 2 or even maybe up to 3 Tesla Powerwalls that are essentially stacked right on top of each other. That's something that's allowed through their listing that is supported by their testing results. So NFPA 855 does make an allowance for that as long as the listing allows for it. Allowable locations, this was, I think, covered a little bit by Chris as well, but attached garages that are separated from the rest of the dwelling by 5/8" Type X gypsum board, which is what our Massachusetts State Building Code would require. That is one allowable location. Outdoors on the exterior wall, as long as it's at least 3 feet from doors and windows. I know Mark had kind of made a reference to that requirement during his presentation. That's another allowable location through NFPA 855. Enclosed utility closets or storage and utility spaces. This one, we kind of put a star next to it because it's not really well defined exactly what that means. There are some communities that have taken the stance that it's not allowed in basements because it's not specifically listed as one of the allowable locations in NFPA 855. There's also an argument that an enclosed utility closet within a basement or a storage and utility space could potentially be a basement, especially if there's no finished space in the basement. Then I would think that in most cases, you would consider a basement to be a storage or utility space. So there's differing interpretations on that, and that is one location that I think could be made more clear by NFPA 855, whether they meant to include basements in the allowable locations or not. Detached garages and any other sort of detached accessory structure are also, of course, allowable and really don't have many requirements associated with those. So if a room or space where an ESS will be installed is unfinished, which again, I know we kind of discussed that a little bit earlier as well, the walls and ceilings of the entire space are required to be then covered in 5/8 inch Type X gypsum board. Because NFPA does not have a definition for what finished means or unfinished means, this has been a difficult requirement to enforce. Because I think, you know, common sense wise, the intent was probably to have some kind of material that is fire resistant or that would provide some level of protection to the combustible structural members of the building. But because it's not clear really what does that mean, what can you have a finished space finished with, and what qualifies there, and it's not clear. So that's something that locally the AHJs are kind of struggling with right now, and installers are kind of struggling with where is the line for when they're required to add that gypsum wallboard. ESS also shall not be installed in living areas or dwelling or sleeping units except within utility closets or storage and utility spaces. So you can't, you know, just throw an ESS in your living room. I don't think anyone wants to do that anyways, but that is in there. We do have a specific requirement, which I think comes up again on another slide, but in 52.9, which is specific to Massachusetts in our fire code, we do require that closets cannot open directly into a sleeping room or a sleeping space unless that home is sprinklered.
So Kristen, just can we back up on that one? Because this comes up quite a bit. You've got an unfinished basement, and now it says the complete area has to be enclosed. And we've had people say, well, we're going to build a room. Is that allowed, or by the code it says the complete basement needs to be enclosed?
No, so I would actually say, and I think this might come up again in a couple slides, but there is a limitation on combustible storage being in the same space as an energy storage system. So I would actually say that in most cases, because most people will have some amount of combustible storage in their basement, that really a separate sort of dedicated closet or utility space that's enclosed for the ESS is almost a requirement in that scenario. Okay. They wouldn't necessarily have to finish the rest of the basement as long as they enclose that
All right,
space.
thank you, because that does come up quite a bit on my end.
Yeah. So NFPA 855 also does have energy rating limitations. 20 kilowatt hours per individual unit is the limit. I don't think there's any manufacturers right now that are marketing units for like residential installations that have a unit that individually is over that capacity. And then aggregate ratings are also limited based on the location. So in a utility closet or storage and utility space that's, you know, sort of within the building, 40 kilowatt hours is the limit. 80 kilowatt hours is the limit everywhere else. So attached or detached garages on the exterior or in any other accessory structure, it can be up to 80 kilowatt hours total system capacity. Fire detection requirements. This is another spot where the language leaves a lot of room for interpretation right now. So that's something that has been kind of, I think, on the docket for the boards to look at and change potentially, make some improvements to that language. But basically, all it says right now is that interconnected smoke alarms need to be installed throughout the dwelling, including in the room, attached garage, or other area where the ESS is going to be installed in compliance with the local building code. In areas where smoke alarms can't be installed, like in a garage potentially, because of the listing and because of the ambient conditions in that space, heat alarms are allowed instead, but those would need to be connected with the smoke alarms in the dwelling. This gets tricky, particularly with pre-1975 homes that have battery-operated smoke alarms. The question has come through a lot about whether those smoke alarms are required to be upgraded, required to be hardwired for power. It doesn't say that right now in the language, it just says interconnected, so potentially you could have battery-powered, interconnected, wirelessly interconnected smoke alarms, and that could be considered compliant. Right now, the way the 10th edition draft reads, that may be changing once the new building code comes out, where essentially an energy storage system installation will become a trigger for a full upgrade to the home, just like adding or creating a bedroom is right now, in terms of adding smoke alarms in all of the required locations and having them all hardwired for power and interconnected. But currently, just with the language in NFPA 855, that is not clear.
The board has specifically addressed that. Chief Aruta's group, or no, Chief Aruta had put a proposal forward. That's going to be changed, or there's a proposed change out there to specifically address that outside the building code, in the fire code.
So impact protection is another sore subject. If Mark was still here, he would attest to this. And he kind of touched on it in his presentation as well, but the requirements for impact protection in NFPA 855 for residential in Chapter 15 are very much open to interpretation by local AHJs. It essentially just says that if it's subject to possible damage from a vehicle, then it needs to be protected by approved barriers. And NFPA's definition of approved is simply acceptable to the AHJ. So that really could be anything that the fire department in that specific community is willing to accept. Many communities are allowing for something like a bollard that's just bolted to the floor, or possibly for the unit to just be located in a location either on the sidewall or high enough up on the wall that it's likely not going to be subject to vehicle damage. But there are other communities that are requiring guard posts, which are specifically defined in Chapter 4, as Mark had mentioned. And that's one of the commercial chapters in NFPA 855, and those are really intended to be for commercial ESS installations. But again, because the language just says approved barriers, it's really open to whatever the AHJ determines is required in that instance. So we also pulled into Chapter 52.9 in the fire code a requirement for construction documents to be submitted and kind of set an expectation of what that should include. This list is essentially already found in NFPA 855 in the commercial chapters for those larger commercial installations, but there were no requirements in Chapter 15 specifically for what kind of documentation would need to be provided for the fire department to review and approve. So we pulled that into the residential requirements as well to kind of set an expectation of what needs to be submitted in order to get a permit. And then specifically again in Massachusetts in 52.9, we added some location-related requirements. This is in addition to what's already in Chapter 15 of NFPA 855. ESS shall only be installed in enclosed utility closet storage or utility spaces that do not open directly into a sleeping area, as I mentioned earlier. And then there's an exception for buildings that are provided with a sprinkler system throughout. Then potentially you could have an ESS in a closet that is opening directly into a bedroom. I don't think that that option is utilized often, if at all, but it is there. And then this that we just touched on a couple minutes ago, combustible storage. So any combustible materials that are not related to the ESS are not allowed to be stored in the room cabinet enclosure containing the ESS. However, there is an exception for that for garages. I think that is because of the challenges of space-wise, creating a separate space within a garage or a separate enclosure. And, potentially not being able to park a vehicle in that portion of the garage anymore. So there is an exception for that, but it does require that combustibles are not stored within 3 feet of the ESS equipment. Obviously, once the installation is completed and signed off on, that's really not something that's going to be able to be policed for the most part. It's something that just has to be self-policed by the homeowner, so they need to be aware of that requirement. But the requirement is there nonetheless, and if the fire department did have a reason to enter that home at some point and notice combustible storage that was too close to the ESS, at least they have a requirement that they can cite to require that storage to be moved. And then a replacement energy storage system. So if an energy storage system is replaced at some point with a new system, then that's considered to be a new installation, and it should comply with the current requirements and regulations that are applicable at the time of that replacement installation, as opposed to whatever was required at the time of the initial ESS installation. In addition to an existing energy storage system, this is something that we have seen quite a bit, where someone maybe installs only one power wall and then later on decides, okay, I need 2 or 3 of these to kind of meet my needs. And so they add a couple more. That is considered to be a new installation. That would need to be evaluated in the aggregate in terms of the overall system capacity and comply with the applicable regulations on that. And then just a couple of frequently asked questions here. So does the installation of an ESS mean that the entire dwelling unit needs to have hardwired interconnected smoke alarms in compliance with today's building code? So again, talked about this a few minutes ago. The language in NFPA 855 right now only requires interconnected smoke alarms. So, pre-75 homes that do not have hardwired smoke alarms would not necessarily need to hardwire them. They may not have interconnected smoke alarms at all, so it might require them to change out all of their devices for a wirelessly interconnectable smoke alarm, so that they could interconnect with that additional smoke alarm that is likely being installed in whatever space the ESS is being installed in. But they would not necessarily have to hardwire the whole home or bring it completely up to current code. Again, on the horizon is a code change that will change that, but for right now, as of today, that's not yet a requirement. What do you do if you come across an ESS installed after October 10th, 2019 that does not have a fire department permit? So that's another common question that has come up. October 10th of 2019, I know I didn't really cover that earlier, was when we first had a requirement for a fire department permit in the fire code. So even though that was the prior edition of the fire code to the latest one that we're using today, a fire department permit still would have been required at that time. And so it would be required to comply with the requirements that were in place at the time of the installation. I think you could make the argument in some cases that it would be required to comply with today's requirements in order to get a permit at this point, but that's really kind of subject to whatever the local fire department feels is a reasonable requirement. So, any other questions? Yes.
One comment, another comment about the listing that we're seeing out there, which is kind of concerning, is that when you have an energy storage system, the energy storage system has to meet UL 9540. It has to be listed, period. The problem is there is a UL cheat sheet that shows a list saying you can be UL 9540, or the battery can be UL 1971, the inverters or whatever, the extenders or whatever, UL 1741. So it looks like it gives a compliance alternative. And what we're seeing is some of these companies, less scrupulous companies, come in and saying, oh, our battery's listed, our parts are listed, so that means it's UL 9540. That is not the case. It has to be UL 9540 listed, period. The other thing that becomes a problem is the Tesla power walls. Those are UL 9540 tested. They're listed by ETL, Intertech. But Intertech has not made the OSHA's list of nationally recognized testing laboratories yet. They're coming in May. So just be aware of that, I don't think that there's going to be a problem, but that has been confirmed by Intertech that they're on the waiting line, they're waiting till May until they are officially recognized by OSHA to test to UL 9540, which I think it's just semantics right now, but if you're doing the research, that's something to be leery of.
All right, question.
There's no requirement, right?
So the question was, if you put an ESS on the plywood, is there a requirement to be fire-rated plywood? I don't know of any myself either on that, but,
So what we've seen,
okay. Go ahead.
So from the audience, they had said that the room would be 5A sheetrock, and then you put the plywood on top of it. So from our experience, from all of these discussions, we don't know. Because you hear some requirements coming from industry saying it's the installation manual that would tell you to dictate that. Other people have said that it's an electrical code requirement. We have not confirmed that through all the electricians here. We have not confirmed that, but it's not a requirement in 855 or the 527 CMR NFPA 1, Chapter 52, or a mass amendment.
Oh, do you have follow-up on that? No, I just have another question. Okay, hold on one second. So, my thought is we can install them on the outside of the structure as long as they're not within 3 feet of windows or openings. It doesn't say restricted to wood shingles, vinyl, anything. So again, and my also thought process is it's going to promulgate out. It's not going to usually go backwards, but it is going to come forward through the box that it's contained in. Okay. Question?
Yeah,
Yeah, so I think it partly depends on,
just repeat the question.
oh, sorry. So the question was, is this a joint inspection between building and fire, where there's a fire department permit specifically required for energy storage systems? Is there also a building permit required? And I think the answer to that is that it sort of depends on what location the energy storage system is being installed in. I think, potentially an outdoor installation, I'm not sure whether a building permit would be triggered by that. I think it's up to the specific circumstances. To my knowledge, there's no specific language in the building code right now that says that an energy storage system installation requires a building permit, but I think sometimes those installations are requiring modifications to the building that will trigger a building permit being needed for that. I think ultimately it's up to the installer to seek a building permit if a building permit is necessary for the specific installation that they're doing. Again, I think there might be some installations where there's really nothing, no permittable activity through the building code. But I think in a lot of cases, a building permit would be required because, as you said, there may be modifications required to the building to make the energy storage system installation comply with the energy storage system requirements. So if they're putting up walls, putting up a closet, sheetrocking, doing all that stuff, then potentially, yes, a building permit would be required for that. But I think that would be a separate building permit application by the installer, not necessarily the fire department
So,
requiring.
no, so so, so on this, it again, as Kristen said, Dave, is that it depends. But we're suggesting to the fire department, as a courtesy, no matter what, to be notifying the building official on that. Because to what Kristen was saying is that we've seen energy storage systems going into storage sheds, 100-square-foot storage sheds. So do you really need a permit for that? What about if it's exterior of the house? Do you need a permit for that? But if it's ever in a structure, I would automatically tell the fire department, as minimal a courtesy, to notify the building official and the electrical official, because we do not know if they're going for an electrical permit. We do not know if they're going for a building permit. So we are suggesting, the marshal's office is suggesting to notify the building official as a mere courtesy, minimally. They should be, Tom should be sending those, or whoever's reviewing that the application comes in. So like what I have seen personally, like in Auburn, it's very rare that we get an energy storage system come into the fire department directly. It's usually matriculating through the portal, going to the building official, going to the wiring, to the electrical. I get it, the fire department gets it, and then I'm the one that has to initiate the conversation that you also have to get an FP6 through the Auburn Fire Department. But again, if they're not putting it into, if they're putting it outside a building, there should be better coordination. I don't disagree to that.
Is there any other questions? No?
At this time, then, I would like to thank our presenters. Let's give them a big round of applause. Thank you very much.